In this course, I'm going to teach you everything you need to know to get started programming in Python. Now, Python is one of the most popular programming languages out there, and it's by far one of the most sought after for jobs. And so if you're trying to get a job, or you're trying to, automate your life, or you're trying to write awesome scripts to do a bunch of different things, then Python's for you. Honestly, more and more developers every day are moving their projects over to Python because it's such a powerful and it's such an easy to use language. A lot of programming languages out there just aren't very beginner friendly. There's a lot of syntax, there's a lot of little things that if you get wrong, the program will yell at you. Python is the complete opposite of that. You basically just type out what you want to do and Python does it. It's that simple. There's not a whole lot of syntax to learn. The learning curve is literally zero. You jump in, you can start writing your first program in seconds. In this course, I'm going to teach you guys everything you need to know to get started in Python. I designed this course especially for Python, and each lesson has been specially designed with examples that will help you along the way. With so many people starting to learn Python, the question isn't why should you learn Python? The question is why shouldn't you? And I think for a lot of people, the reason they might not want to learn Python is because they're intimidated or they're afraid that it's going to be too hard. Trust me, I'm going to hold your hand through this entire course. We're going to talk about all the core concepts in Python. We're going to look at everything you need to know to start programming in Python and start being confident and start writing scripts and start writing programs that are awesome and doing cool things in your life. Anyway, I'm super pumped to be teaching you guys Python. I can't wait to get started in this course, and I hope you guys stick around and follow along with the course and learn this amazing programming language. In this tutorial, I'm going to show you guys how to install Python onto your computer. And we're also going to install a text editor that we can use to write our Python programs in. So the first order of business is to actually install Python on your computer. So what we want to do is head over to our web browser, and you want to go over here to this page. It's just www.python.org/downloads. And on this page, there's going to be two buttons down here, and it's just going to say download Python 3.6.3. And at least that's the version that I have right now, or download Python 2.7.14. So here's the thing about Python. There's actually two major versions of Python that are in use currently. There's Python 2 and there's Python 3. So you can see over here, this is like 2.7.14. Basically any Python 2 version we would just refer to as like Python 2. And here's like the latest Python 3 version. And so there's these two versions that you can download, and the first thing we have to decide is which version do we want to download. And here's the basic difference. Python 2 is a legacy version of Python, which basically means that it's like an old version and it's not being like actively maintained or supported like officially by Python anymore. Python 3 is like the future of Python. It's like the newest version. It's the one that's getting actively maintained and supported. And so there's pros and cons to picking either one. A lot of people will say like Python 2 has been around longer, and so there's more like libraries. There's basically just more Python code written in Python 2. So therefore, like there's a few more things that you can do in Python 2 than you can do in Python 3. But then again, Python 2 is not supported, and 5 or 10 years from now, probably no one's going to be using it. Python 3, like I said, is like the future of Python. It's the newest version. It's the one that is sort of being maintained going forward. So for the purposes of this tutorial, I'm going to be teaching you guys Python 3. So we're going to want to download Python 3. Now, here's the thing. Like, if you learn Python 3 or you learn Python 2, the differences aren't very big. There are a few differences in like some syntax and just some, little things here and there. But if you learn Python 3, you'll be able to jump right in and code in Python 2 as well. Don't let anyone, tell you that you have to learn one or the other. We're going to learn Python 3 just because it's, I think, probably the best for a beginner to learn. And so that's the one that we want to download. So I'm just going to click download Python 3, and we're going to go ahead and download this version. And when that's done downloading, I'm just going to head down to my downloads folder. And you'll see here we just have this file. I'm just going to double click, and we get this like Python installer. So I'm just going to click through here, and we'll be able to install Python 3 on our computer. All right, when that's done installing, we can just close out of this and we should be good to go. So now we have Python 3 installed on our computer. The next step is we need to choose a text editor. So we're going to be writing a bunch of code. So we're going to need some, environment or some program that we can write all that code in. And really, you can write Python in any text editor. You could write it in like Notepad or TextEdit. It doesn't really matter. But there are special text editors that are designed just for writing Python code. And these are called IDEs, and that stands for Integrated Development Environment. It's basically just a special environment where we can, run and execute our Python code, and it'll, basically like tell us how we're doing. So if we're, if we write something that's wrong or we have errors, it'll kind of point us in the right direction of what we need to do to fix that stuff. So in this course, we're going to be using an IDE, and one of my favorites and one of the most popular IDEs for Python is called PyCharm. So I'm over here on this website. It's called jetbrains.com/PyCharm. And this is the IDE that we're going to be using in this course. So I'm just going to come over here and click this big download now button. And we'll go ahead and download this PyCharm program. All right, so I'm getting this page over here. You can see there's two versions of PyCharm. One is a professional version, and that one's like paid, so you have to pay for it. But then there's this community version down here, and that's free and open source. So I'm just going to download this one. And this should have everything we need to get started using Python. All right, when that finishes downloading, I'm just gonna pull that up in my downloads folder. And again, we can just sort of run this guy. And I'm on a Mac, so I'm gonna have to drag it over to my applications folder. All right, so we now have PyCharm and we have Python 3 installed on our computer. So we're ready to start programming in Python. In this tutorial, we're going to create our first Python program, and we're going to be able to run it and see how everything works. The first thing I want to do is open up PyCharm. So PyCharm was the IDE, the Integrated Development Environment, that we downloaded in the last tutorial. So I'm just going to go ahead and search for it on my computer, and I can just open it up. And when we first open up PyCharm, we should basically just get a window prompting us to create a project. So you can see that down here. Actually, the first thing I want to do though is come over here to configure, and I'm just going to click on preferences, and I actually want to change the appearance. So I'm going to go ahead and give this a theme. So I just went over here to appearance and behavior, appearance, and I'm going to change the theme to Darkula, just because I think it's a little bit easier to use and look at. But you don't have to do that if you don't want to. And so down here, I'm just going to click Create New Project. And it's going to give us this little window right here, so I can just name my project, and I'm just going to name this Draft. And then there's this other option down here where it says Interpreter. Now, what we want to select is Python version 3. So if I click down here, you'll notice that there's a couple different options. So I'm on a Mac computer, and by default, Mac has Python version 2 installed on it. If you're on a Windows machine, I'm not sure if it does, but in this tutorial, we're going to be using Python 3. So you want to make sure that you have Python 3 selected as the interpreter. Otherwise, you might not be able to fully follow along with what we're doing in this video. So now I'm just going to come down here and click Create, and this is going to go ahead and create our project for us. All right, so now we have our Python project up and running, and I want to show you guys how we can create our first Python program. So over here in this draft folder, and this is just that project that we created, I'm just going to right click and I'm going to say New, and I'm going to come down and click Python file. So we want to create a new Python file. This will be our first Python program. And I can just give this a name. So why don't we just call this app, and I'm just going to click OK. All right, so now we have our first Python file open, and we can just start typing in some Python. So I want to show you guys just a very basic Python program, and this is just going to be a hello world program. So we're just going to print something out onto the screen. So what I want to do is I want to type out print, and I want to type in open and close parentheses. Now inside of this parentheses we can make some quotation marks, and inside of the quotation marks I'm just going to type out hello world. So this is like a very basic Python program, and what this is going to do is it's just going to print out hello world onto the screen. And so now what I can do is I can actually run this file, and we're actually getting a little error here. It wants us to create a new line at the end of the file. And so now in order to run our Python program, I'm just going to come up here to the top, and I'm just going to click run, and we'll click this run button right here. And now we'll see what happens. So it's asking me what I want to run. I can just click app, And down here at the bottom, you'll notice that we have this text that just got printed out, hello world. And so whatever I print or whatever I put inside of this print statement is going to get printed out down below in the console. So as long as you're getting that print statement to work, then you've actually written your first Python program. And as we go forward in the course, we're going to be writing all sorts of awesome Python programs, and we're going to be doing all sorts of cool stuff. In this tutorial, I want to talk to you about writing a basic Python program. So we're going to write just a very simple Python program. We're going to look at how we can go ahead and write our programs. We're going to talk about how our programs are getting executed by Python. And we're also going to draw out a little shape onto the screen. So this is going to be pretty cool. I'm excited to talk to you guys about just the bare basics of Python and really just sort of give you an introduction. So over here, we have our basic text editor. And so any of the Python code that I write inside of this file is actually going to get executed by Python. So this Python file has a bunch of Python code inside of it. And basically what we're doing when we're programming in Python is we're just giving the computer a set of instructions, right? That's really what programming is. It's just like we're specifying a set of instructions and the computer is going to go off and execute those instructions that we give it. And so the more complex the instructions we give to the computer, the more complex the tasks the computer can carry out. So I want to show you guys how we can use some Python instructions or some Python code in order to draw out a shape onto the screen. So I'm actually going to draw out a little triangle. So over here, we can actually print something out onto the screen in Python using something called a print statement. So I can just type out print, and inside of these parentheses, I can just type some quotation marks, and inside the quotation marks we can put whatever we want to print out onto the screen. So I'm going to copy this, and I'm actually going to make a few of these little print statements, and we're going to actually draw a shape. So we're going to draw like a triangle type shape. So down here I'm just going to draw a forward slash, and then up here I'll make a space and we'll do another forward slash. Here we'll make 2 spaces, we'll do another forward slash, and over here we're going to make 3 spaces and a forward slash. And now I'm going to draw like vertical bars going all the way down. And actually we can do some underscores here as well. That'd be kind of cool. Alright, so now we have our triangle looking shape, and you can see it looks kind of like a right triangle. So I can save my file, and I can either come up here to run and click run app, or if you're using PyCharm, you can also just come over here and click this play button. And when I click the play button, I want you to notice what happens down here. So down here we have this little window, and this is called the console. And basically the console is just a place where Python is going to output some information. So when we use this print statement, we're basically telling Python like, hey, can you print something out onto the console? So there's a lot of situations where we're going to want to see what's going on in our code. And we can use that print statement and print things out to the console, and we can basically like have a little window into what our program's doing. In our case, we're just going to be printing out this triangle onto the console. So I'm going to come over here and click this play button, and you'll see down here we're actually printing out that triangle. So mission accomplished, we were able to print out our shape. So I could really draw any shape I wanted as long as I was able to specify it inside of these print statements. So essentially what Python's doing when I click that play button is it's going into this file and it's looking at all of these instructions in order. So the first thing it does is it goes to this instruction and it says, okay, they want me to draw out these like little forward slash and this vertical bar onto the screen. Once it does that, it goes down to this instruction. It says, okay, they want me to print something out again. When it prints that out, it goes down to this instruction, etc. So Python is actually going to execute the lines of code that we write in order. So the order in which I write the instructions matters a lot. So for example, if I was to take this last line here and put it up here at the top, now when I save the file, instead of just drawing out that triangle, it's going to draw out this little upside down bottom thing at the top and then the rest of the triangle down here. So the order of the instructions actually matters a lot. And so this is basically how your Python programs are going to go. As we go through this course, we're going to learn more and more of these little lines. So here we're just using this little print function. Basically, it just prints something out onto the screen. There's a bunch of little things like this that we can learn, and as we go through, we'll learn more and more instructions that we can give to the computer. But in this lesson, I just want to kind of show you guys the basics, right? We can essentially just define these little instructions for the computer, and the computer will execute them in order. In this tutorial, I want to talk to you guys about using variables in Python. Now, in Python, you're going to be dealing with a lot of data. And so a lot of times in our program, we're going to be working with all types of information and data and values. And sometimes that data can be difficult to manage. So in Python, we have this thing called a variable. And it's basically just a container where we can store certain data values. And when we use a variable, when we put those data values inside containers, it makes it a lot easier for us to work with and manage all of the different data inside of our programs. So variables are extremely helpful, and it's sort of like a core topic in Python that you're really going to want to know and master. So in this tutorial, I'm going to teach you guys everything you need to know to get started with variables. We're going to look at what they are, why they're useful, and we'll look at the different types of variables and the different types of data that we can store inside of variables. So over here in my Python file, I just have a very simple program, and it's basically just printing some text out onto the screen. And so this is actually a little story that I wrote. It says, "There once was a man named George. He was 70 years old. He really liked the name George, but didn't like being 70. So this is a valid Python program. I could go ahead and run this program, and you'll see down here in the console, everything prints out and it looks great. So we have an awesome little Python program here. But let's say that inside of our story, I wanted to change the character's name. So instead of naming the character George, let's say I wanted to name the character John. Well, I'm going to have to go through and I'm going to have to manually change the name George to the name John at every place inside of this story where it's mentioned. So I'm going to have to go over here and I'll say, okay, John, I'm going to have to manually change that. And then, okay, down here, we're going to have to, again, manually type in John and change it to John. So in order to change the character's name, I had to manually go in and change it in both places. And now let's say, okay, maybe we want to change the character's age also. So in addition to changing the name, we also want to change the age. Let's make him a little bit younger. So why don't we say John is going to be 35. And so you'll see here I had to come here and manually change the age, and then come down here and manually change it again, right? And now that we changed it, like, it's going to work, it's going to be updated in our program. But you'll notice that in order to make that change, like, I had to look through the entire program, find where that value was, and change it. And this was only with 4 lines of the story. Imagine if I had a story that was like thousands of lines long, and we mentioned the character's name and age like hundreds of times. I mean, I'd have to look through each one of those lines and manually change the character's name. And that is not a very good way for us to do this. And it's really not a good way for us to manage the data in our program, right? The character's name and the age. And so we can actually use a variable in order to store the character's name and the character's age. And when we use that variable, it'll make it a lot easier for us to put the character's name and age inside of our little program here. So I'm going to show you guys how we can create a variable for the character's name and age. And I'm just going to go up here above this print statement. And up here, I want to create a variable. So when we create a variable in Python, we actually need to give Python a couple pieces of information. The first piece of information we need to give Python is the name of the variable. So I need to actually assign a name to this container where we're going to be storing information. And so all I have to do is just type out the name of the variable that I want to create. So I'm going to create a variable called character name. So I'm just going to say character, and I'm going to say underscore name. And so generally when you're creating a name for a variable in Python, you want to separate different words with an underscore. So I have 2 words here and I'm separating them with an underscore. And now what I need to do is I need to put a value inside of this variable. So basically what I can do is I can just say equals, and over here I can type a value. So I'm just going to type out the character's name inside of quotation marks. So we're just going to type out John. So now we have a variable for the character's name. And below this character name variable, I want to create another variable called character age. So I'm just going to type out character underscore age, and I'm going to set this equal to the character's age, which is 35. So we now have two variables, one representing the character's name and one representing the character's age. So what I can do now is I can replace the character's name inside of the story with this variable. And I'm going to show you guys how to do that. So if we want to put a variable inside of this print statement, I'm actually going to have to do a couple things. The first thing I'm going to have to do is end off this text in here. So I'm going to have to put a quotation marks here at the end. And you can see I'm basically wrapping this whole thing into a single like quoted line. And now I also have this text over here at the end, so I'm going to have to put a quotation mark here. So now I have a bunch of text here in quotation marks, and then I also have text over here in quotation marks. Now inside of here, instead of saying the character's name, I want to refer to that character name variable. So I'm just going to say plus character underscore name, and I want to say another plus sign. So I basically am saying I want to print out all of this text plus the value that's stored inside of character name plus all of this text. And what this will do is it'll actually print out the character's name when we print this. So I'm going to go ahead and run this program, and you'll see down here, and actually let me put a space over here and we'll run it again. So you can see down here we still are printing out there once was a man named John. And so what Python is doing is when it executes this line of code, it's coming over here and it's seeing, oh, okay, they want to print out the value inside of character name. So Python's going to go up here, it's going to get the value, and it's going to insert it inside of there. So I can basically do this for every instance of the character name in my file. So I can, I'll just copy this guy right here, and I can just paste it down here where the character's name is. So I'll paste this, and you can see now we're doing exactly the same thing that we did up there. I can also do this for the character's age. So I'm going to come down here and I'll paste in what we just pasted in. And I'm going to change this. Instead of character name, we'll change it to character age. And I'm going to do this in one more spot. So we're going to do this over here where we're mentioning the age. And again, I'll just change this to character age. And so now when I run this program, it's going to print out the same story that we were printing out before, but now I don't actually have to type in the character's name and the character's age. I can just refer to this variable. And the cool thing about variables is if I wanted to change the character's name, now all I have to do is change it up here. So I could change the character's name to like Tom or something, and we could also change their age. So I could change the age to be like 50. And now that's going to automatically update throughout our entire story. So when I click this play button, you'll see now we're using the name Tom, and he's 50 years old. So that's where variables can come in handy, and this can be a really awesome way to control and manage the data that's inside of our programs. With variables, you can also modify their values. So for example, let's say that halfway through the story I wanted to change the character's name. Well, I can just make some new lines over here, and down here I can actually assign a new value to one of these variables. So I could say like character underscore name, and in order to give it a different value, all I have to do is just say equals, and we'll give it a different value. So let's say halfway through the story we want to change the character's name to Mike. Well, now when I run on my program, you'll see here in the first part of the story it says there once was a man named Tom. And in the second part of the story, it's referring to the name as Mike. So I actually updated the variable inside of my program over here. And that's a really awesome way. A lot of times in these programs, you're going to want to be modifying the values of variables. And so you can do it just like that. And so finally, I want to talk to you guys about the different types of data that we can store inside of these variables. So over here, I have the character name and the character age. And I'm actually storing what are called strings. So a string is basically just plain text, right? So the name Tom, that's just plain text. Down here, these guys are strings as well. So there's a data type in Python called a string, and it's just basically going to store plain text. So, any text that you would have like in a story or, someone's name, you can store inside of a string. There's also another type of data that we can store inside of Python, which is numbers. So in addition to storing text, we can also store numbers. So if I wanted to store a number, for example, let's say we wanted to store the character age instead of inside of a string, we could store it inside of a number. So I could just type out 50. And when we're storing a number, we don't need these quotation marks. You only need that quotation mark when you're storing a string. So if I wanted to store a number, I can just write it out like this. And in addition to using whole numbers, I could also use decimal numbers. So I could say like 50.5678213. And Python's going to be able to store that number as well. So you can store all different types of numbers, and we can also store what's called a Boolean value. And a Boolean value is essentially a true or a false value. And there's a lot of instances in programming where we're going to want to represent true or false data. For example, I could have a variable called like is male, and this would tell me whether or not someone was a male. And in my case, it would be true because I'm a guy, right? So I can, actually this needs to be capital. So I could store a value of either true or false. And actually, if we were naming this in Python, we'd want to use an underscore. So I would say is underscore male, and this can be either true or false. So true or false values is maybe not something that you're used to dealing with like in the real world. But in programming, we're going to be using true or false values all the time. They're super important. So like I said, there's three basic types of data that we can work with in Python. There's strings, which is just like plain text. Numbers, which would be like either decimal numbers or whole numbers like this. And there's true or false values. And these are the basic types of data. I mean, there's a bunch of other types of data that we can use, but I would say 99% of the time as a new user and a new programmer to Python, you're just going to be dealing with these three types of data. So those are the basics of the data, and also with variables. And you're going to be using variables all the time in Python, so you definitely want to practice up and get comfortable using them. In this tutorial, I want to talk to you guys about working with strings in Python. Now, one of the most common types of data that we're going to be working with in Python is going to be strings. And strings are basically just plain text. So any text that we want to have inside of our program, we can store inside of a string. So I want to talk to you guys about all the cool things we can do with strings, and we're basically just going to get a full introduction into why strings are awesome. So over here, I'm just going to actually print out a string. So I'm just going to say print, and inside of these parentheses, I can type out a string. In order to create a string, I need to use quotation marks. So I can make an open and close quotation marks, just like that. Now, inside of the quotation mark, I can put whatever text I want the string to have. So we could say like Draft Academy. And so now we have a string with the text Draft Academy inside of it. So if I run my program, now down here we're going to print out Draft Academy, as you can see. And when we have these strings, there's actually a bunch of cool things that we can do with them. So one thing I could do would be to create a new line inside of the string. So if I wanted, I could come over here and I could say \n, and you can see it got highlighted in a different color. And what this is going to do is it's actually going to insert a new line into the string. So now it's going to say draft on one line and academy on another line. So I'm going to click play, and you'll see down here we just get Draft Academy. In addition to the \n, I could also use a / quotation mark. So if I wanted to put a quotation mark inside of my string, I can't just put a quotation mark like that, because Python's going to think that I'm trying to end this string. So if I want to include a quotation mark, I can just use this special / character, and that's called the escape character, and it basically just tells Python that whatever character comes after it, we want to render literally. So when I say / quotation mark, it basically means like, hey Python, I want to print out a quotation mark. And so now we'll be able to print out a quotation mark right there. I can also use this to print out a \. So if I needed to print out a \, I could say \, and it'll just print out a normal \ now. So you can see just like that. So if you want, you can use that \ to make new lines or print out quotation marks, or you can just use it as a normal \. In addition to just typing out a string here, I could also create a string variable. So I could come down up here and we can create a variable, and we'll just call it phrase. and I'm going to set it equal to Draft Academy. So I can store this string value inside of a variable called phrase, and then when I want to print out that variable, or I want to access that string variable, I can just type the name of the variable, and you'll see that it's going to print out the value that was stored inside of it. I can also use something called concatenation. And concatenation is basically the process of taking a string and appending another string onto it. So I could come over here and I could say phrase, and I could say plus, and now I can add in another string. So I could say like is cool. And now this is going to say Draft Academy is cool. So I'm basically appending another string onto another one. They call that concatenation. And so in addition to doing all that stuff, we can also use special things called functions. And a function is basically just a little block of code that we can run, and it'll perform a specific operation for us. And so we can use functions to modify our strings, and we can also use functions to get information about our strings. So I'm going to show you guys a couple common functions we can use with these strings, and they're actually going to do awesome stuff. So in order to access one of these functions, I can just say phrase, and then I can say dot. And I'm going to show you guys a function that we can use to convert this string entirely into lowercase. So I could just say phrase.lower, and then I'm going to want to type in open and close parentheses. And this will take this phrase, it'll take my string, and it'll convert it to lowercase. So you can see now we just have Draft Academy down here, but it's entirely in lowercase. I could also do the same thing for uppercase. So I could say phrase.upper, and this will convert the entire string into uppercase. So you can see now it's entirely uppercase. So in addition to converting the string into uppercase and lowercase, I could also check to see if a string is entirely uppercase or entirely lowercase. So for example, I could say phrase.isUpper, and this is going to give me back a true or a false value. So it's going to be true if the string is entirely uppercase, or false if it's not. And you can see here we're getting a false value because this isn't uppercase. I can also use these functions in combination with each other. So for example, I could say phrase.upper, and then a parentheses, and then after this I could say dot is upper. And now what it's going to do is it's going to run this upper function, it's going to convert it into uppercase, and then it's going to run this is upper function right after that, and you'll see now we're going to get a true value back because it will have converted the whole thing into uppercase. So you can see now we're getting a true value. So you can use these functions one after another. It can be really useful. And there's a few other ones that I want to show you. So we can also figure out the length of this string. So if I wanted to figure out how many characters were inside of this string, I could just say len, and I'm actually going to make an open parentheses, and I'm going to make a close parentheses. So I'm essentially saying len, and this is another function, it's the length function. And inside of this len function, I'm actually passing this phrase variable. I'm basically giving the length function this, and it's going to spit out a number. So it'll tell me how many characters are inside of this string. And so you can see here we get 15 because there's 15 characters inside of Draft Academy. So that's how we can get the length of a string, and that's going to be really useful as we go forward in Python. We can also get individual characters inside of a string. So imagine if I wanted to just grab one of these characters. Like imagine if I wanted to figure out what the first character in this string is. Well, I can actually use an open and closed square bracket just like that. And in here I can specify the index of the character that I want to grab. So if I wanted to grab the first character in this string, I can put in a 0. So if I say phrase square bracket 0, this is going to give me that capital G. And you can see down here, that's what gets printed out. Now I want to point something out. In Python, when we're working with strings, a string gets indexed starting with 0. So you'll notice that in order to access this G, I had to put a 0 in here. And that's because in Python, when we use indexes on a string, we start with 0. So if Python is counting the characters, or it's indexing the characters in a string, it's going to start with 0. So it's going to say G is 0, I is 1, R is 2, A is 3. So we would say that G is at position 0 in the string, I is at position 1, R is at position 2, A is at position 3, etc. So we start counting at 0. So if I wanted to access the first character in the string, this G, I have to say phrase 0. And that's just a special thing in Python, and actually most programming languages do that, so they'll start with 0. So for example, if I wanted to access this A, I'm going to have to put 0, 1, 2, 3. So if I put 3 inside of here, now we'll be able to access that first A. As you can see, we get an A right here. So this is actually really useful, being able to grab a specific character inside of a string, and you're going to be using that a lot as we go forward in Python. There's also another really awesome function that we can use, and it's called the index function. And basically what the index function will do is it'll tell us where a specific character or string is located inside of our string. So I could say phrase.index, and I can actually give this a value. So sometimes when we use these functions in Python, we can actually give them information. So I can give this a value. And we would call this passing a parameter. So I would call a value that I would give to a function a parameter. And you'll hear that word a lot. So for example, I could say inside of here, capital G, and now this is going to return the index of the capital G inside of our string. So it should give us back a 0 because G is at the 0th index. And you'll see down here that we get a 0 because that's where G is. So for example, if I put an A inside of here, like a lowercase a, it should give me 0, 1, 2, 3, because that's where the first A is inside of this string. So I can click the play button, and you'll see it's giving us a 3. You can also put actual words in here. So for example, I could put like academy in here, or I could even just put like ACAD, and this is going to tell me where this starts inside of my string. So when I click play, it's going to give me an 8 because that's where academy starts, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. If I put something in here that wasn't in the string, so for example, if I put a Z in here, that's not in here, it's actually going to throw an error. So when I play this, you'll see that we get this error down here because Z is not found inside of our program. So that index function, again, can be really useful, and we'll be using that a lot. There's also one more that I want to show you, which is called replace. So we can say phrase.replace, and in here, I can actually give this 2 parameters. So I can give this replace function 2 values that it can use. And the first thing I want to give it is what I want to replace. So for example, I could say draft, and then I'm going to put a comma in here, and I want to put in here what I want to replace draft with. So I could just say like elephant, and now instead of saying Draft Academy, this is going to print out Elephant Academy. So you can see down here it just says Elephant Academy. So this replace function can be really awesome because we can replace certain words or even certain letters inside of our strings with other ones. So those are just some basic ways that we can work with strings inside of Python. And there's a lot of these different functions that we can use with strings. These are some of the most common, the ones that I just showed you right now. But if you just do a Google search, you can find all sorts of Python functions that you can try out and use and see what they do. But you definitely want to get comfortable working with strings in Python because you're going to be working with them a lot. In this tutorial, I want to talk to you about working with numbers in Python. Now, numbers are one of the most common data types in Python, and any Python program you write is most likely going to be dealing with numbers at some point. So I want to talk to you guys about just the basics of using numbers. We're going to talk about the different types of numbers that we can represent in Python. And I also want to show you guys some awesome functions that we can use with numbers. So we can do certain like mathematical operations. We can do some awesome things with numbers. And I'm going to show you guys all of that in this video. It's going to be awesome. So first thing we can do is we can actually just like print out a number. So if I want to write a number in Python, it's really easy. I basically just write the number. So I could say like print 2, and this is just going to print the number 2 out onto the screen. So I can use a whole number like this. I could also use a decimal number. So I could say like 2.0987. And Python's going to be just fine with that. We'll be able to print that out onto the screen as well. I can also make numbers negative. So I could make this 2.0987 a negative number, and Python will be able to handle that just fine too. In Python, we can also use basic arithmetic. So I could do things like addition, subtraction, multiplication. So I could say like 3 plus 4. And now this is going to print this out. Or why don't we say like 3 plus 4.5. And this will be able to print out the answer, so we get 7.5. And we can do addition, we could do subtraction, we could do division, or we could do like multiplication as well. So you can pretty much do whatever you want inside of Python. And if you want to make more complex mathematical equations, we can also use things to specify order of operations. So I could use parentheses. So for example, if I said 3 times 4 plus 5, what Python's going to do is it's going to multiply 3 and 4 together. So it's going to be 12, and then we'll add 5 to that. So we should get 17. But let's say that we wanted to change up the order, right? I could actually put a parentheses around 4 and 5. And now it's going to add them first, so it'll add 4 and 5, so we'll get 9, and we'll multiply that times 3. So we should end up with 27. So you can see we can use those parentheses to specify order of operations. So I could make like a very complex little equation here just by using numbers and parentheses. We can also use one other operation, which is called the modulus operator. So I could say like 10 and use this percent sign 3. And this is actually read 10 mod 3. And basically what this is going to do is it's going to take the first number, divide it by the second number, and it's going to spit out the remainder. So it's basically going to say, okay, 10 divided by 3, that's going to be 3 with a remainder of 1. And so this is going to give us the remainder. And you'll see down here we get 1 because that's the remainder of 10 divided by 3. And that modulus operator can come in handy quite a bit. We can also store these numbers inside of variables. So we can store them inside of these variable containers. So I could come over here and I could create a variable called like my underscore num, and we'll just store a value of, let's say like 5 in here. And so I could come down here and I can just print out my underscore num, and we'll be able to print that number out to the screen just fine. So in addition to doing things like basic arithmetic, we can also do some other stuff. So one thing I could do is I could actually convert this number into a string. So if I wanted to convert this number into a string, I can just say str, and I can put the number that I want to convert inside of these parentheses. And so what's going to happen now is this number is going to be converted into a string. So when I click the run button, you'll see it's just printing out 5, but now instead of being a number, this is actually a string. And this is going to come in handy when you want to print out numbers alongside strings. So I can come over here and I can say like my favorite number, and we'll be able to print this number along with this string. So I can click play and it says 5, my favorite number. If I was to get rid of this string right here and I wasn't converting the number into a string, now Python's going to have a problem with this. It's not going to allow us to do that. You can see we get an error. So anytime you want to print out a number next to a string, you got to make sure that you use that little string function. So there's a bunch of other stuff that we can do with numbers, and a lot of times in Python you're going to want to be using specific like more advanced math operators. So there's a bunch of different math functions that we can use on our numbers. And a function is basically just like a little collection of code that does something. So a function could perform an operation like a mathematical operation on our number. It could also give us information about our number. So I'm going to show you guys some of the most common functions that you'll be using in Python related to numbers. The first one is called ABS, and it stands for absolute value. So we can get the absolute value of a number. And so over here, I'm just going to make this variable -5. And basically, I can just say ABS, and I can make an open and close parentheses over here. And this is going to give me the absolute value of this number up here. So when I click the play button, you'll see it's just giving us 5, because 5 is the absolute value of -5. I can use a few other functions. There's another one which is called POW. It's just POW. And I'm actually not going to use this variable. We just use a normal number. And this function is going to allow us to pass it 2 pieces of information. So I can give this function 2 pieces of information. The first is going to be like a number, and the second is going to be the power that I want to take that number to. So I could say like 3, 2, and this is basically just going to be 3 raised to the power of 2. So it's just going to be 3 squared, so we should get 9 down here. You can see that we do. So I could pass in like, you know, some crazy number, like we could pass in a 4 and we could raise it to the power of 6. And so we should get like a pretty big number here. And you can see we get 4,096. So this pow function is really useful for taking numbers to specific powers. So in addition to using this pow function, we can also use another function which is called max. So I can say max, and what this is going to do is it's basically going to return the larger of the two numbers that we pass into it. So right now I'm giving this a 4 and a 6, and this should tell us which number is higher. So over here it's just printing out 6 because that's the bigger number. I can also use another function called min, and this is going to do the opposite. So now instead of printing out the max number, it's going to print out the smallest number, and it's going to print out 4 down here, as you can see. Another cool function is called the round function, and this is going to allow us to round a number. So it's just going to follow like standard rounding rules. So if I said like 3.2 inside of here, now it's going to round it down to just normal 3. But if I said like 3.7, it's going to round it up to 4. So that'll allow you to round a number. So there's a few other functions that I want to show you guys, but in order to get access to them, I'm actually going to have to do something called importing. And in Python, we can actually import external code into our files. And so if I want to access these specific math functions, I have to import something called Python math. So I can just say from up here, math, import, and this star. And basically what this is going to do is it's going to go out and it's going to grab a bunch of different math functions that we can use. So I already showed you guys a few of these different math functions, but there's actually a bunch more. And in order to access them, we're going to need to include this line of code inside of our file. So once we have that, now I can access a few others. So there's another function which is called the floor method, and it's just floor. And what this will do is it'll basically just grab the lowest number. So it's essentially just going to chop off this decimal point. And you can see over here now we get a 3 because we're using that floor function. There's also another one called ceil, and that's just going to do the exact opposite. So that's just going to round the number up no matter what. So no matter what, we'll always get 4 if we have a 3 point whatever here. And there's another one which is called square root. So it's just sqrt. And essentially this is just going to return the square root of a number. So I could say like 36, and now we should get 6 back. So those are all some very interesting functions. And inside of this math module, so we would call this a module. And you don't have to worry too much about what that is right now. Just know that when we put this line of code into our program, it gives us access to a lot more math functions. So it basically allows us to do a lot more things with math inside of our program. And there's a bunch of different math functions in Python. And if you want, you can basically just go online and search for different math functions. I showed you guys a few here, and I would say the ones that we looked at here are probably the most commonly used, but there's a bunch more. And like I said, you know, there's tons of documentation on all of this stuff. So you can just look up, you know, math functions in Python, and there's going to be tons and tons, like lists of these things that you can use inside of your programs to perform different math operations. But for now, that's just been a little bit about using numbers, a little bit about doing, you know, certain math operations and using functions with those numbers. In this tutorial, I'm going to show you how to get input from a user. So we're basically going to allow a user to input information into our program. And I'm actually going to take the information that the user inputs, I'm going to store it inside of a variable, and then we're going to be able to do something with that variable. So I want to show you guys how we can actually go about getting input from someone. And down here in my Python file, all I have to do to get input from someone is I just have to type out input and then an open and closed parentheses. And what this is basically going to do is it's going to tell Python like, hey, we want to get input from a user, and Python will allow the user to type in some information. And inside of these parentheses, we can actually type a prompt. And so generally when we want the user to enter in some information, we want to tell them what we want them to enter. And that's what we can put inside of here. So I'm just going to say, enter your name. So we're actually going to create a little Python app which is going to allow the user to enter in their name, and then we'll store the name inside of a variable, and then we'll basically just say hi to the user. So we'll say like hi, and then whatever the name they entered was. So what I want to do is I actually want to store whatever the user inputted into our program inside of a variable. So I can actually go over here and I can create a variable. I could just call it name, and I could set this variable equal to input. So what I'm doing now is I'm taking the value that the user inputs and I'm storing it inside of this variable container called name. And so now I have access to whatever they entered in. So what we can do is we can say print, and inside of the parentheses I can just print out hello, and then I'm just going to add on to this name. And actually, why don't we put an exclamation point? So essentially we're getting a name from the user, we're storing it inside of the name variable, and I'm printing it out onto the screen. So I'm going to go ahead and play this. And when we run the program, you'll notice down here, Python is giving us this little prompt. So it's saying, enter your name. And now in here, I can actually type in a value. So I can type in Mike, and then I can just hit enter. And Python's gonna go ahead, store this value inside of that variable, and then it's gonna print out hello Mike. And so this is kind of cool. And actually what we could do is we could prompt the user to enter in more than one piece of information. So I could actually copy this line of code, and I'm going to paste it below here. And why don't we have the user enter in another variable? So we could have them enter in, for example, their age. And over here, we just want to say enter your age. And so now we're able to get two pieces of information from the user. And I could say hello name, and then I can say you are, and I'll print out their age. So I'm just going to print age. So now I'm basically able to get both of these pieces of information from the user. I can get their name and I can get their age. So when we run this program, I can type in both of those pieces of information. So it'll say enter your name. So we could just make up a name like John, and then enter the age. Let's say John is 25. And now it's going to say, hello John, you are 25. So the program is able to get input from the user, and then it's able to use that information in order to say hi to the user and tell them how old they are. And so getting input from the user is a great way to make your programs more interactive. And here we're just scratching the surface, right? We're just basically getting two, pieces of information from the user, but you can use these inputs to do awesome things in Python. And as we go through this course, you're going to see some really cool things that we can do with these inputs. In this tutorial, I'm going to show you how to build a very basic calculator in Python. We're basically going to build a calculator where we'll get two numbers from a user, and then we'll add those numbers together and print the answer out onto the screen. So this will give us some practice in getting input from users, and we'll also talk about getting numbers from users as opposed to just strings. So I'm really excited to get started on this calculator. The first thing we want to do is create two variables, and inside of those variables we want to store the two numbers that the user wants to add together. So down here I'm just going to say num1, and that's what we'll call our first variable, is equal to, and now I need to get input from the user. So I'm going to say input, and inside these parentheses I'm going to say enter a number. And now I basically want to do the same exact thing, but for the second number. So we'll paste this guy down here, and I'm just going to say num2, and then we'll just say enter another number. So now we're able to store the user's input inside of these two variables. So now all I want to do is just print out the result. So I'm actually going to create a variable called result. So I'm just going to say result is equal to, and basically we just want to add these two numbers together. So I'm going to say num1 plus num2. And now all we have to do is just print out the result. So I'm just going to print result. So we basically have our entire program written out here, and this will allow us to enter in two numbers, and then we'll add them together and print out the answer. So I'm going to click play, and down here we can enter our number. So I'm going to enter the first number, we'll say 5. and I'm going to enter my second number. So let's say 8.0, or let's say 8.3. So now it should print out the answer. But if you look over here, that's not quite the answer we were looking for, right? 5 plus 8.3 is definitely not 58.3. And here's what happened. When we get input from a user, by default, Python is just going to convert it into a string. So it doesn't matter what we put down there when we're entering the numbers. Python's always just going to be like, okay, this is a string, that's it, sounds good, right? It's just going to make it a string. In order for us to make these num1 and num2 variables numbers, we're actually going to have to convert the strings that we get from the user into numbers. And so the way that we can do that is by basically just coming over here, and when we add the two numbers together, I can use a special Python function in order to convert those strings into numbers. And there's actually two Python functions that we could use for this. The first is called int. So I could say int, I can make an open parentheses, and I can make a close parentheses. And basically what this is going to do is it's going to convert whatever is inside of these open and closed parentheses into an integer number. And an integer number is basically a whole number. So it's like 1, 2, 3, 4, 5. So it's a whole number. In other words, it can't have a decimal point. And so what I could do is I could say int, and I could put these inside of parentheses. And now what this is going to do is it's going to convert both of these numbers into integers. In other words, into whole numbers that don't have decimals, and it's going to add them together and we'll print out the result. So why don't we do that, and we'll just see if this works. So I'm going to click the play button, and down here we'll enter our first number. So I'm just going to enter in a 4, and then I'll enter in a 5. And now you can see it's printing out the correct answer, 4 plus 5. And so that's essentially our basic calculator. But we do have one problem with this calculator. So I'm going to run it again, and I'll show you guys what that problem is. If I wanted to add in a decimal number, so we'll add 4.3 and 5.5, you'll see that we're getting this error. And that's because I'm using this int function up here. And this int function is looking for a whole number. So if I put decimal numbers inside of there, it's going to break the program. There's another function we can use. Instead of an int, we can say float. And a float is basically just a number that has decimals. So it's a decimal number. And so I can convert both of these guys into floats. And now I'll be able to use decimal numbers. So I can click play, and I can just enter in some numbers. So I could say like 4, and I could also say like 5.5. And now it's going to be able to add both of those numbers, even if one of them is a decimal. And that's the beauty of using that little float function. So in certain circumstances, you might want the user to only be able to enter in an integer, so a whole number. But in a lot of cases, like in this calculator, we want them to be able to enter any number that they want. So we're going to use this float function. So I'm just going to recap what we did one more time. We created two variables, num1 and num2. And we basically stored the two numbers that the users inputted into those variables. And then we converted them into numbers, and we added them together, and we printed out the results. So this is a pretty cool calculator. I'm happy with it. Hopefully you guys learned something. And as we go forward in this Python course, you're going to learn all sorts of ways that we can make this calculator more complex. In this tutorial, I want to show you guys how to build a Mad Libs game in Python. So a Mad Libs game is basically just a game where you can enter in a bunch of random words, so like, you know, verbs, nouns, names, colors, and you basically take all of those words and put them into a story randomly. So over here, my web browser, I just have an example of a Mad Libs. So, you know, down here, we're basically just taking random words like an adjective or a noun or a plural noun and entering them inside of a story. So like you read through the story and then like some random word pops up. And Mad Libs can be pretty fun, and I'm sure you guys have, you know, at least heard of Mad Libs before. But if not, that was just a little introduction. So I want to create a Mad Libs in Python, and this is going to be really cool. So down here I have this like little poem which just says, "Roses are red, violets are blue, I love you." And so, you know, this is kind of like a classic poem, but I think we should mix it up a little bit and create a Mad Lib for this poem. And so instead of having this red color over here, I want to have the user enter in their own color. Instead of having violets, why don't we have them enter in a plural noun? And instead of saying I love you, why don't we have them say I love and then some celebrity. So celebrity. So this is the basic structure for our little Mad Lib, right? I want to basically have the user enter in a color, enter in a plural noun, and enter in a celebrity. And then I'll take all of those words and put them inside of our Mad Lib, and hopefully we end up with something that's pretty funny. So how can we actually go about building this in Python? Well, the first thing we're going to have to do is we're going to have to be able to get these words from the user, right? That's pretty obvious. So I think what we should do is we should create 3 variables called color, plural noun, and celebrity, and we'll store the user's inputs inside of those variables. So up here, let's create those variables. The first variable I want to create is going to be called color. So we'll say color, and I want to set this equal to the input. So I'm going to say input, and inside of here, I'm just going to give them a prompt. So I'll say enter a color, and we can basically just copy this line of code, and I'm going to paste it down below, and we'll paste one more time. So now we're going to create our plural noun variable. So I'll say plurao, plural noun. And we'll just say enter a plural noun. And actually over here I want to make a colon as well. So then finally we'll create our celebrity variable, and we'll say enter a celebrity. And so now basically we're creating 3 variables called color, plural noun, and celebrity. And inside of them we're storing the color that the user enters, the plural noun the user enters, and the celebrity the user enters. So the last thing we have to do is replace these guys with those variables. So I'm basically just going to add in the color over here, and we're going to add in the plural noun. So I can just go like this. And finally, we'll just add in that celebrity. So now we have a pretty cool Mad Lib, and it should be functional. Everything should work. It looks like it's good to go. So let's come over here and we'll run our program, and then down here in the console we can play our little Mad Libs game. So let's say enter a color. I'm just going to say magenta. Enter a plural noun. Why don't we say microwaves? And enter a celebrity. Let's say Tom Hanks. So when I click enter, what should happen is we should get our Mad Libs printed out. So I'm going to click enter, and now we have our Mad Lib. So it says roses are magenta, microwaves are blue, I love Tom Hanks. So it's a pretty good Mad Lib, and obviously, you know, the more print statements we put over here, you know, the better the Mad Lib could be, and we could store as many, you know, variables up here as we wanted. This was just a very simple Mad Lib. We only took in 3 inputs, but you know, you could see how you could take something like this and create a little Mad Libs game. So your homework for this lesson is to go off and make your own Mad Libs game, hopefully one that's a little bit funnier than mine. But that's the basics of creating a Mad Libs game in Python. In this tutorial, I want to talk to you guys about working with lists in Python. A lot of times when you're programming in Python, you're going to be dealing with large amounts of data. And when you're dealing with large amounts of data, you want to make sure that you can manage it and organize it properly. And a list is essentially just a structure that we can use inside of Python to store lists of information. So we can take a bunch of different data values, we can put them inside a list, and it allows us to organize them and keep track of them a lot easier. So generally you would create a Python list and you would put a bunch of related values inside of that list, and then you can use it throughout your program. So I'm going to show you guys just the basics of using lists. We're going to look at some of the common use cases and really just get you up to speed with what lists are and why they're useful. So over here in my program, I'm actually going to create a list, and we create a list a lot like we create a Python, just like a normal Python variable. So the first thing we want to do when we're making a list is give it a name. So we want to give it a descriptive name, something that's going to basically describe what's inside the list. In my case, for this example, let's make a list of like friends. So we could say like, here's a list of all my friends. So I can say friends, and I'm going to set this equal to the list of values that represent my friends. And when we want to create a list, we can use these open and closed square brackets. So whenever you use these open and closed square brackets, Python basically knows, okay, they want to store a bunch of values inside of this list. So why don't we go ahead and start adding some values? So we can say like my friends are like Kevin, Karen, and let's say Jim. So here I have 3 values inside of my friends array. So when we're creating a normal variable in Python, generally we just give it one value, right? So I would create a variable, I would give it one value, maybe a string or a number or a Boolean. But when we make lists, we're able to store multiple values inside of the same like little item, inside of the same object, right? And then what I can do is I can access these individual items inside of my program. So inside of this friends list, we're basically storing all of these different values, and that can be really useful. So now that we've stored some values, let's talk about what you can put inside of a list. So you can really put any piece of information in Python. We could put things like strings, numbers, or Booleans. So if I wanted, instead of just putting strings here, I could change like one of these to a number, and I could change one of these to a Boolean, and it wouldn't matter. Python's going to be fine with that. But let's change these back to strings just for the sake of the example. So now that we've created our list, how can we access individual elements inside of this list? It's a good question. I'm going to go ahead and print something out to the screen. The first thing we can do is we can just print out the actual list. So I can just say print friends, and then when I run this program, if we look down here in the console, you can see it's just printing out the actual list of friends, right? But let's say that I wanted to print out a specific element inside of this list. Well, I can actually refer to elements by their index. So each one of the elements inside of this list has a particular index. And the indexes actually start at 0. So we would say that this first element in the list, Kevin, has an index of 0. We would say that this other element, Karen, has an index of 1. And this third element, Jim, would have an index of 2. So even though Jim is technically the third element inside of the list, it has an index of 2. And that's because we start indexing at index position 1. And so that's just kind of how lists work, and that's how list indexes work. So if I wanted to access a specific element inside of my friends list, I can just refer to it by its index. So over here, after we type out friends, I'm just going to type an open and closed square bracket. And inside of this open and closed square bracket, I want to put the index of the element inside the list that I want to access. So if I wanted to access this guy right here, this element, I can just put a 0. So I can say friends 0, and now when I run my program, it's just going to print out that value. It's just going to print out Kevin. If I wanted to access this Jim value over here, I can put a 2, and that will give us that Jim value. You can see right there. So we can access elements based off of their index. We can also access elements based off of their index from the back of the list. So for example, if I said -1 inside of here, this is going to give me access to this value right here for Jim. And you can see that's what it does. So when we use negatives, it starts indexing from the back of the list. So if I said -2, this is going to give us Karen. And so you can use the negatives to access items at the back of the list. Just keep in mind though, and this is kind of interesting, we would say this first element here is index position 0, right? But we would say the first element at the back of the list is index position -1. So just keep that in mind. So there's actually other ways that we can access like just portions of this list. So for example, let's say I just wanted to select the last 2 elements in this list and I didn't want to select the first one. Well, in here, I can just say 1 with a colon, and this will grab the element at index position 1 and all of the elements after that. So now we should just grab Jim and Karen, or Karen and Jim in that order. I could also specify a range. So actually, let me add in a couple other elements just so that we can illustrate this better. So I'll add in 2 more names. So if I wanted to, I could select like the element at index position 1 up to the element at index position 3. So it's going to grab this one, so that's 1, 2, and it's actually not going to grab the third one. So it's going to grab all the elements up to, but not including 3. So it'll grab Karen and Jim. So So let's go ahead and run this, and you can see it grabs Karen and Jim. So you can either just put like 1 with a colon after it, and then it'll grab that index position and everything after it, or you can specify like a range that you want to grab from. So that's how we can access elements inside of this list, but we can also modify elements. So for example, I could come down here. Let's say I want to modify this value right here, Karen. Well, all I have to do is just access that element. So I could say friends, and Karen is at index position 1. And I could change this to whatever I want. So I could say friends index position 1 is equal to Mike. And now when we print out friends index position 1, that value is going to be updated. So it's just going to say Mike instead of saying Karen. So it can be really useful to modify values inside of arrays. So it can be really useful to modify values inside of Python lists. So those are kind of the basics of working with lists in Python. And actually in the next tutorial, I'm going to show you guys even more ways that we can use these lists. We're going to learn how to like add elements to a list, delete elements from a list, copy lists, and a bunch of cool stuff with these lists. But for now, this has just been sort of like the basics of working with lists. In this tutorial, I want to talk to you guys about using functions with lists in Python. In Python, a list is one of the most important structures where we can store our information. A list basically allows you to take a bunch of different values and organize them and store them inside of their own little list structure. So down here in my program, you can see I have 2 lists. I have a list of lucky numbers, and this is just a bunch of different numbers. And then I have a list of friends. So this could be like a list of somebody's friends, and it's basically just a bunch of strings with names in them. So these 2 lists are storing a bunch of different values. And what makes lists awesome is not only could I store like this many values, I mean, I could store hundreds or thousands or millions of values. And when you're working with a lot of data and a lot of information in Python, these lists are invaluable. So because lists are so important, there's actually a bunch of different functions that we can use with lists. And those functions allow us to do things like modify the lists and get information about the lists. So in this tutorial, I just want to show you a bunch of those functions. We're going to talk about some of the most common and the most popular functions that you would use on lists to make them more powerful and make them more easy to use. So the first thing we can do is obviously just print out a list. So down here, I'm printing out this friends list. And when I run my program, you see down here, we're just printing out all the elements in the list. So it's always good to be able to print out all the elements inside of a list. But there's a lot of other functions that we can use. So one function is called the extend function. And the extend function will basically allow you to take a list and append another list onto the end of it. So I could say like friends.extend, and inside of these parentheses, I can pass in the list that I want to add on to the friends list. So I could say like lucky numbers. And now when I print out this friends list, not only is it going to have all the elements in the friends list, it's also going to have all the elements inside the lucky numbers list. You can see down here we have all of our friends, and then we also have the numbers over here. So that's a really easy way to essentially just like add 2 lists together. We can also just add individual elements onto a list. So I could come down here and I could say friends.append, and this will actually allow me to append another item onto the end of this list. So over here, I could just add another name. So we could say Creed, for example. And now I'm like adding another friend onto the end of this list. So when I run the program, in addition to having the original items that were in the list up here, we also have this additional item at the end. And that append function is always going to add the item onto the end of the list. But let's say that you wanted to add an item into the middle of the list, so like right here or right here. There's another list function called insert. And insert is going to take 2 parameters. The first parameter is going to be the index where you want to insert the item. So why don't we insert it here at index position 1. I'm just going to say 1, and then I'm going to type in the name of the element that I want to add. So we can just say like Kelly. And now at index position 1, we're going to have the value Kelly, and all of these other values are going to get pushed up. They're going to get pushed to the right 1 index position. So now when I run the program, you can see we have Kevin, this new element Kelly, and then all the other elements have been pushed off to the right. We can also remove elements. So for example, let's say I wanted to remove this gym value. All I have to do is just say friends.remove, and I can just type in whatever element I want to remove. So I want to remove this gym element. And so now when we run the program, gym is going to be gone from the list, and we just have these 4 guys left. You can also remove all of the elements from the list. So if I just wanted to completely like reset the list and get rid of everything, I could just say friends.clear, and this is gonna give us an empty list. So it'll get rid of every single element inside the list. There's also another really cool method which is called pop, and you can just type out pop like that. And basically what pop's gonna do is it's gonna pop an item off of this list. So when I click the play button, you'll see here that we're left with Kevin, Karen, Jim, and Oscar. So we basically got rid of the last element inside the list, and that's what pop does. It pops an element off of the list. So it basically removes the last element in the list. So we have our list, but let's say that we wanted to figure out if a certain element was in this list, right? If a certain value is in here. So let's say I wanted to check to see if my friend Kevin was in this list. Well, I could say friends.index, and in here I can just pass a value. So I could say like Kevin, and this is going to tell me the index of Kevin. So it'll tell me if Kevin's in the list. So now when I click play, you can see down here it says 0. If I was to say like Oscar in here, for example, now it'll give me the index of Oscar. So that's at 3. But if I put a name that wasn't in here, so like if I put Mike, that's not in the list. And so now we're going to get back an error because it says Mike is not in the list. So that's an easy way to figure out if a specific element is inside of the list. And if it is, then you'll know what index it's at. You can also count the number of similar elements in the list. So I'm actually going to come down here, copy this gym element, and we'll add another gym element into here. So I could come down here and I could say friends.count, and we'll pass in gym. And this will tell me how many times the value gym shows up inside of this list. So it should say 2, which it does down there, because we have 2 values with the text gym. And so we have all these values. We could also sort this list. So I could come over here and I could say friends.sort. And what this will do is it'll sort the list in ascending order. So we have a bunch of text here, and you'll see what it does. Basically what it's going to do is it's going to put it in alphabetical order. So you can see we have J, K, O, and T. So the list went from being just random order, like whatever we had up here, to now it's in alphabetical order. And that's also going to work for lucky numbers. So I could say like lucky numbers dot sort, and then we'll print out lucky numbers. And these should now be in ascending order, which I'm realizing they already are up here, but if I was to take this 42 and put it down here, now it will figure everything out and put it in ascending order anyway. We can also reverse a list. So if I wanted, I could reverse this lucky numbers list. I could say lucky numbers dot reverse, and now when we print it out, instead of being 42, 8, 15, 16, 23, it's going to be 23, 16, 15, 8, 42. So it's basically just reverse the order of the list. And finally, there's one more list function I want to show you guys, which is copy. So I could actually create another list, and I could make it as a copy. So I could say like friends2, and we could set this equal to friends.copy. And now friends2 is going to have all the same attributes as friends, because it's basically just like copied. It basically took a copy of that friends list. So you can see it's the same exact thing. And copying lists can come in handy in a lot of different situations. So those are just some basic list functions, and just to kind of like, you know, get your feet wet in working with lists. Obviously, like the more you work with them, the more you practice using these different functions, the more comfortable you're going to get. But that's just kind of like a basic overview of what you can do. In this tutorial, I want to talk to you guys about tuples in Python. Now, a tuple is a type of data structure, which basically means it's a container where we can store different values. Now, if you're familiar with lists in Python, a tuple is actually very similar to a list. It's basically a structure where we can store multiple pieces of information. But a tuple has a few key differences from lists that we're going to talk about in this tutorial. First thing I want to do is I want to show you, though, how to create a tuple. So I can come down here and I can create a tuple, and one of the most common examples of tuples is coordinates. So let's say I had a series of like XY coordinates. I could create a variable called coordinates, and I'm just going to set this equal to an open and close parentheses. And whenever we want to create a tuple inside of Python, we're going to use these open and closed parentheses. And inside of here, inside of these parentheses, we're going to put the values that we want to store. So I could, for example, put a list of numbers. So this could be like my coordinates. I could have like 4 and 5. So this would be my tuple with coordinates inside of it. And one of the things about tuples that makes them unique is a tuple is immutable. And you'll hear that word a lot when we're talking about tuples, immutable. It basically means that the tuple can't be changed or modified. Once we create our tuple up here, you cannot modify it, you cannot change it, you can't add elements to it, you can't erase elements from it, you can't change any of the elements inside the tuple. What you see is what you get. Once you create the tuple, it's as it is, it can't change. So I could come down here and I could print out some of the attributes inside the tuple, and the way I can access them is just by using an open and closed square bracket, and in here I can pass in a index. So tuples are indexed starting at 0, so technically we would say that 4 is at index position 1, and 4 is at index position 0, and 5 is at index position 1. So if I said coordinates 0, now it should print out 4. And down here, we're printing out 4. So if I wanted to print out that 5, we can just put a 1 inside of those square brackets, and now we'll print out that 5. So I can access the elements inside of a tuple. I can easily access each entry, but if I was to come over here and try to change one of the elements, so if I said coordinates and coordinates 1, and I tried to set it equal to something else like 10, Python's actually going to give us an error when we run this program. So I'm going to run the program. You see we get this error. It says type error tuple object does not support item assignment because it's immutable, because we can't change it. So that's basically what tuples are, how we can create them, and a tuple, like I said, it's very simple. You just create it and then you have it. And now I want to talk to you guys about a common topic in Python, which is the difference between tuples and lists. So remember, a list is basically doing the same thing. A list, if we wanted to create a list, we would just use square brackets instead of those parentheses. And if I was using a list, I could assign different values to it. I could basically mutate any of the elements. I could add, delete, modify, change, whatever I wanted with the list. But with a tuple, we can't do that. And that's sort of the basic difference. And really, Python doesn't say anything more than that. It basically just says like one of them's immutable, one of them's not. But in practical use cases, generally people will use tuples for data that's never going to change. So you'll store data inside of a tuple when that data doesn't need to be mutated. That's why something like coordinates is such a good candidate for a tuple, because once you have coordinates, like, we're probably not going to modify them, right? We might add other coordinates. So for example, if I wanted, I could create a list of tuples. So I could say like 4, 5, 6, 7. Maybe we have some other coordinates like 80, 34. So here I have a list, and inside of it we have these tuples. But remember, these tuples can't be modified. The values can't be changed. So really, it's just a case-by-case basis. I would say by a huge majority, you're going to be using lists most of the time. Tuples are more of a niche. They're used in more special situations. But there are plenty of situations where you want to use tuples. So if you're in a situation where you want to store data that can't be changed or mutated, then tuples are the way to go. So yeah, that's just some basics about tuples, some basics about the difference between lists and tuples. And so a tuple is a great thing to add into your Python repertoire. In this tutorial, I want to talk to you guys about using functions in Python. Now, a function is basically just a collection of code which performs a specific task. So I can take a bunch of lines of code that are basically doing one thing, I can put them inside of a function, and then when I wanted to do that task or do that one thing that the function was doing, I can just call the function. And so functions really help you to organize your code a lot better. They allow you to kind of break up your code into different, little chunks that are doing different things, and they're really just awesome. So functions are like a very core concept when we're talking about programming in Python. So I'm going to show you guys how to create an awesome function today. Let's say for the purposes of this tutorial, we want to create a function that says hi to the user. So the one task that our function performs is basically just saying hi to whoever is writing the program. So over here, if I want to write a function, the first thing I have to use is a keyword in Python. It's called def, so D-E-F. And basically when Python sees this keyword, it's going to say, oh, okay, this person wants to use a function. So after we type out def, we need to give this function a name. So just like when we are creating variables, we give them descriptive names, we also want to do the same thing with functions. So if I'm creating a function, I can just give it a specific name which basically says like what it's doing. So we're going to create a function that says hi. So I'm just going to call this function say hi, just like that. And once we type out the name of the function, and so also I could type out say hi with no underscore, or I could type out say hi with an underscore. Both are considered like good practices in Python. A lot of times, if you just have a simple like two-word function like this, you don't need to put an underscore, but we could put an underscore there if we wanted. After we type out the name of the function, I'm just going to type an open and close parentheses, and then I'm going to type a colon. And basically what this is doing is it's saying to Python like, all right, all the code that comes after this line is going to be inside of our function. And in order to write code that's going to end up being inside the function, we actually have to indent it. So over here, you'll notice that when I clicked enter, my text editor automatically indented the text. So it's automatically like using this indent here. And that's kind of like one of the rules in Python is like the code that goes inside of this function needs to be indented. So if I was to write some code like out here, this is no longer going to be considered inside the function. So you can see as I type out code, and obviously this isn't real code, but as I type text over here that's indented, this little like marker over here is basically saying like, oh yeah, that's inside the function. But then when I write code over here that is like not at the same indentation level as this stuff, it's no longer considering it inside the function. So that's just a little thing. Any code inside this function needs to be indented. All right, so our function is just going to say hi to the user. So I'm just going to have it print out some text. It's going to say hello user. So this is a very simple function. Obviously, we just have one line of code, and inside of a function, you could have as many lines of code as you want. But for our purposes, we only need one line in order to perform our function. So now all we have to do is call this function. So if I want to execute the code inside of this function, I have to do something called calling it. So if I was to just run my program as it is right now, I'm just going to run it. You'll see that nothing happens over here, right? Even though this function is printing out hello user, when I run the program, it's not doing it. And that's because the code inside of a function isn't going to get executed by default. The code inside of a function is only going to get executed when we specify that we want to execute it. And in order to do that, we're going to have to do something called calling the function. So in order to call the function, you basically just type out the function's name and those open and close parentheses. So I'm just going to type out say hi and open and close parentheses. And now when we run this program again, you'll see that it prints out hello user. So we're executing the code inside of the function. And I want to show you guys just one more thing here, just talking to you guys about how these functions actually work. So up here I'm going to print top, and then down here I'm going to print bottom. So I want to show you guys the flow of these functions inside the program. So when I run this program, you'll see we print out top, hello user, and then bottom. So essentially what's happening is when Python goes through and executes this program, it goes over here to this first line. It says, okay, we want to print out the word top. And then it goes down here and it says, okay, we want to execute the say hi function. So Python actually jumps up and it goes over to this say hi function, and it's going to execute all of the code inside of this function. So it's going to go through, execute all of this code, and then once it's done executing all of the code in the function, it's going to jump back down here and it's going to move on to the next line, which is bottom. So that's kind of like the flow of functions. Again, with functions, generally when we're naming these functions, you want them to be named in all lowercase. And usually when we're naming stuff in Python, if there's 2 or more words, we're going to use an underspace or an underscore in between them. So I could write this out as say underscore hi. But in a lot of situations though, if I have a function like this where the name is really short, it might just be easier to leave it without an underscore. But why don't we just put an underscore in there just to be super Python official. Alright, so now we can actually make these functions a little bit more powerful. And what we can do is we can give them information. So a lot of times when we write a function, we're going to want to have additional information that gets passed in. And these are called parameters. So a parameter is a piece of information that we give to the function. So over here, I can actually specify that this function needs to receive some parameters. So I can basically say like, hey, if you're going to call this function, you need to give us some information. You need to give us some parameters. And all I have to do that is just type out the name of the parameter that I want to receive. So why don't we allow the code calling this function to tell it what name to say hi to. Up here, I can just say name. And basically what this means is it means whenever I call this say hi function, we have to give it a name. So down here, if I was to call this, I have to include a name in here. So I can say like Mike. And what we can do now is we can actually access this parameter or this variable inside of our function. So I could come over here and instead of saying hello user, I could say hello name. And basically what this is going to do is it's just going to say hello to whatever name got passed in here. So I'm actually going to copy this and we will do this twice. So I'll say hello Mike, hello Steve. And now when I run this program, you'll see that instead of just saying hello user, it's saying hello to whichever name I passed into the function. So that's why this can be really useful, right? We can give the function information, and depending on the information we give it, it'll perform its task a little bit differently. I could also include more than one parameter. So you can, I mean, technically you could have like as many parameters as you want. So I can put another one in here, we could say age, and now I'm gonna have to pass in an age along with these. So I'm just gonna pass in an age and pass in an age for down here. And I'm just gonna pass in strings. So we can say hello name, you are age. So I'm passing in 2 pieces of information, and now when we run this program, it's going to call the function, and it's going to use both of those pieces of information. So I'll say, hello Mike, you are 35, hello Steve, you are 70. So essentially, we're writing out this one line of code, which just prints out like hello to someone, and we're allowing this function to receive 2 parameters, so the name and the age. And depending on the name and the age, the function is going to print out hello a little bit differently. And that's kind of the beauty of using functions. So you could pass anything you want into a function. So for example, I could pass in a integer instead of a string for the age. So like I could pass in a number. The only difference is over here we're going to have to convert this into a string. But it's going to work just the same. So you could pass in strings, numbers, booleans, arrays. You can really pass any type of data into a function and it's going to work. So you can see here we get the same result. So that's the basics of functions, and as you go through with Python, you're going to be using functions more and more. And generally, it's a good idea to break your code up into different functions. So whenever you have like a grouping of code that's designed to perform a specific task, that's usually a good candidate to be put inside of a function. In this tutorial, I want to talk to you guys about using the return statement in Python functions. Now, a Python function is basically just a collection of Python code that performs a specific task. And when we want to perform that task in our Python programs, we can call a Python function. And a lot of times when we're calling a Python function, we just kind of call it and it does its thing and then we move on with the program. But sometimes when we call a function, we're actually going to want to get information back from that function. So when I call the function, I want it to basically execute its task. I want it to execute all the code. And then I want it to give me some information back. So that could be like a particular value. It could be something like telling me how the task went. Basically, the function can just communicate back to us like, hey, here's some information. And that's what the return keyword can allow us to do. The return keyword can basically allow Python to return information from a function. So I'm going to show you guys how we can do this. I want to create a very simple function, and it's just going to cube a number. So when we cube a number, we take it to the power of 3. So if I was going to cube 2, it'd be 2 raised to the power of 3. Right? It's just pretty basic math. So we're going to make a function that will cube a number, and I'll show you guys how we can use that return statement. So first thing we want to do is make a function. I'm just going to say def cube. We'll call the function cube. And over here we can specify any parameters that this function will take. So basically any values that we want to give this function. So we're going to give it one function, which is just going to be a number. So I'm just going to call it num. And then over here I'm going to type out a colon. And then down here, we can put any of the code that we want to be included in this function. So basically, this function is just going to cube this number. So we could just type out num times num times num, right? That's going to give us num cubed. So that's all well and good. And if I come down here, I can execute this function. So I can basically just call it, I'll say cube. And why don't we pass it a 3? So I'm going to go ahead and pass it a 3. And I'm going to save this. And now let's go ahead and run this code. So we'll run the code, and you'll see down here, nothing happened, right? So nothing got printed out in our program. In fact, when we called this cube function, it didn't really do anything. So let me try to print this out. So maybe if we print this function out, it'll give us back the information that we want. So type out print, and we'll print out the value of the function. I'm just going to click play. If you look down here, it says none. So when I printed out the value of this function, it told me none. But really, this function is supposed to be cubing the number. And here's how we can use the return statement in Python. I can come over here and I can just say return. And now Python is going to return whatever value we put over here to the right. So when I call this cube function and I give it a 3, Python's going to go off, it's going to execute this function. When it sees this return statement, it's going to say, okay, I want to give a value back to whatever called this function, and it's going to return this value. Now, when I print out cube 3, it should print out the answer because we get an answer back. So when I play this, you'll see down here, it says 27, so we got the correct answer. So I could do this with anything. Why don't we cube 4 or something? So now I'll run this, and you can see we're constantly getting the correct answer back. So that's the basics of using this return statement. It allows us to return a value back to the caller. In other words, back to whatever's calling the function. So I just want to illustrate this point a little bit further. I'm going to come up here. I'm actually going to create a variable. So I'm going to create a variable called result, and I'm just going to set it equal to cube 4. This variable result is going to store the value that gets returned from the cube function. So it's not going to store cube 4, it's going to store the value that gets returned from executing that function. So now if I came down here and printed out result, it's actually just going to print out 64 again because that's the value that it's storing. So this return statement can be really useful for getting information back from a function. We can use something like a parameter, like this 4 is a parameter, and we can give information to a function, and then we can use the return statement to get information back from a function. And I do just want to point out one more thing. I'm actually not able to put any code after this return statement. So if I came down here and tried to put like a print statement, this actually isn't going to work. So this is never going to get printed out. So if I just typed out like code right here, when we run this program, it's not going to type out code. That's because when I use this return keyword, it breaks us out of the function. So Python's going to go through, it's going to execute the code in the function. Whenever it sees this return keyword, it's just going to break back out and we're going to be done. So we'll never be able to reach this line of code. So that's the basics of using return statements, and you can return any data type you want. We could easily return like a string or a Boolean or an array. It doesn't really matter. You can return whatever you want. And a lot of times, in a lot of situations, you're going to want to get a value back from a function. In this tutorial, I want to talk to you guys about using if statements in Python. Now, if statements are a special structure in Python where we can actually help our programs to make decisions. So by using an if statement, I could execute certain code when certain conditions are true, and I could execute other code when other conditions are true. So basically, if statements allow our programs to respond to the input that they're given. So depending on the data that we're using in the program, our programs will be able to respond. So when certain data is certain values, we can do certain things, and when other data is other values, we can do other things. So your programs are essentially becoming a lot smarter. And actually, if statements are things that we as human beings deal with every day. So as you go throughout your day, generally you're dealing with if statements all the time. So I want to kind of give you guys a brief introduction into if statements, and we'll talk about some of the common if statements that you'd see in everyday life, and then we'll go ahead and do a really awesome example to kind of like show you guys what if statements can do for us. So over here in my text editor, I just have this little text file, and in here I wrote out a bunch of if statements that a lot of people will encounter on a daily basis. So here's the first one. It says, I wake up, if I'm hungry, I eat breakfast. So let's break this down a little bit. Up here it says, if I'm hungry. And this is a condition, right? This is either going to be true or it's going to be false, right? If it's true, I'm going to go ahead and eat breakfast, right? If it's false, I'm just going to skip whatever was in here and move on, right? So that's the basics of an if statement, right? We have a condition, in this case, if I'm hungry. If the condition's true, then we do the action, so we eat breakfast. Otherwise, we just skip it. So down here we have another one. It says, I leave my house. If it's cloudy, I bring an umbrella. Otherwise, I bring sunglasses. And so this one is a little bit more complex than the one we just looked at. You'll see we have our condition, right? It says, if it's cloudy. If that condition's true, we're going to bring the umbrella. But in this case, if the condition's false, there's something else that we want to do. So in the case up here, if this condition was false, we just moved on. But now, if this condition's false, then we're going to go ahead and bring sunglasses. So that's another example of an if statement. It's a little bit more complex. Finally, I have one more down here, and this one's even more complex. It says, I'm at a restaurant. If I want meat, I order a steak. So if this condition's true, we order the steak. But if this condition is false, then we're going to move on, and we're actually going to check another condition. So I'm going to say, otherwise, if I want pasta, I order spaghetti and meatballs. This is another condition. If this condition's true, we get the spaghetti. If it's not true, then finally we're going to move on down here, and we'll just default to ordering the salad. So all three of these if statements are valid if statements. It's just they get more and more complex as we go down the list. So hopefully that's, you can kind of wrap your head around what if statements are. We're basically specifying conditions. If those conditions are true, we're going to do certain things. And if those conditions are false, we can do other things. Or we can check other conditions. All right, so let's head over to our Python file, and we'll start writing some actual Python. So in here in my app.python file, I want to create an if statement. And I'm going to show you guys a very basic if statement in this tutorial. And then in the next tutorial, we're going to look at some more advanced if statements. And so what I want to do is create a Boolean variable. So I'm going to create a Boolean variable that's going to store whether or not the user is a male. So it's just going to be called is_male. and I'm going to set this equal to true because I'm a male. So we have this Boolean variable, right? And right now we have it set equal to true. I can actually use an if statement to check to see what the value of this variable is, and if it's true, I can do something. So if I want to use an if statement, all I have to do is just type out if, and then I just need to type out a condition. So basically I would have to type out like something that's going to be true or false. Like, for example, in the other page we were specifying like if I'm hungry or if it's cloudy. Here we're just going to check to see if is male. So in other words, if the person is male. And so remember, this has to be it has to be able to be reducible to a true or a false value. So in our case, we're just using a Boolean because that's like the easiest thing we can do. So I said if, I specified my true or false condition, and now I want to just type a colon. And what I want to do now is make a new line. And so anything that I put below this with an indentation is actually going to be executed when that condition's true. So I could put print, and down here I could just put you are a male. And now you'll see what happens when I run this program. It's going to go down here and it's going to say you are a male. But if I changed is male to false, so instead of this being true, I just change it to false, now all of a sudden it's not going to print anything. So it's just going to be blank down here. That's because this condition wasn't true. So anything that I put below this if declaration and that has an indentation like that is going to be executed when the if statement is true. We can also use another keyword in Python, which is called else. And else is basically going to be like otherwise. So you remember before we said, if it's cloudy, I'll bring an umbrella. Otherwise, I'll bring sunglasses. Well, this is going to be like our otherwise. So I can say down here, else. And now anything that I put below else is going to get printed out when that condition isn't true. So why don't we just put, you are not a male. So now we're able to cover both of the situations for this variable. If it's false, we can cover that situation. So it says you are not a male. If it's true, we can cover that situation as well. So it'll say you are a male. So that's pretty cool. But we can also make these more complex. And actually, before I talk about that, you can put as much code as you want inside of an if statement. So I could have like, dozens of lines of code if I wanted. I'm just giving you guys a very simple example. So why don't we make this more complex, and I'm going to add another variable into the mix. So I'm going to add another, Boolean attribute into this mix. I'm going to make another variable called is tall, and we're going to set this equal to true as well. So now I have two variables in the mix. Let's say I wanted to write an if statement that will check both of those variables. So I could write an if statement that's like, if they're male and they're tall, or if they're male and they're not tall, or if they're not male and they're tall. Like, I could write out a bunch of if statements to check the combination of these variables. And so the way I can do that is by using one of two keywords. So the first keyword I want to show you guys is the or keyword. So I can come over here and I can say if is male or is underscore tall. And what this is basically going to do is it's going to say if the person is either male or if they're tall, then we want to do something. So this is only going to be true when one of these values is true, when one or both of those values is true. So down here we could actually put, instead of you are a male, we could put you are a male or tall or both. That's going to be more appropriate. And then down here we would say you are neither male nor tall. And that's because if we execute the code inside of this else, that means that both of these guys are false, right? So I'm saying if they're male or they're tall, we're going to execute whatever is in here. Otherwise, that means they're neither male nor tall. We're just going to execute this down here. So let me show you guys how this works. I'll click play, and these are both true. So it's going to say you are a male or tall or both. If I was to set one of these to false, so let's set is male equal to false. Now, it's still going to say you are a male or tall or both. But if I set them both equal to false, now it's going to say you're neither male nor tall. So that's kind of the basics of using the OR operator. And there's another operator we can use which is called AND. And basically it's similar to OR, except both of these conditions have to be true. So this is basically saying if the person is male and they're also tall, then we're going to execute whatever's in here. So we could actually change this text to say you are a tall male, because we know for a fact that if this is getting executed, they're both male and tall. We can also change this print statement down here. This could say you are either not male or not tall or both. So you can see it's basically just saying that you're either not one of them or you're not both of them. So we click the play button and you'll see because they're both false, it's going to say you are either not male or not tall or both. But if I make them both true, now it's going to say you are a tall male. If I was going to make one of these false though, so let's make is tall false, now it's not going to execute this first print statement, it's going to execute the one inside of the else. So it'll say you are either not male or not tall or both. So that's the basics of and or, and you'll be using those a lot as you use your if statements. But there's actually one more thing we can do. We can add in some more conditions. So up here I'm checking if they're male and they're tall, but what if I wanted to check if they're male and they're not tall? So if they're like a short male. I can use another keyword in Python called else if, or really it's just typed out ELIF, and it stands for else if. And after this we can put another condition. So over here, I'm going to check to see if they're male and they're not tall. So I'm going to say else if male is male, and now I can type in not tall. And the way I can do that is by saying not and open and close parentheses and saying is tall. And basically when I use this not function, it's going to negate whatever is inside of here. So if this was true, it's going to make it false. And if this was false, it's going to make it true. So basically that'll tell us whether or not they're tall. And then I'm going to use a colon, and now down here, inside of here, we're basically just going to type out any of the code that we want to happen when this condition's true. So down here we can just print out you are a short male. And there's actually one more condition that we want to check for, which would be if they're not male and they're tall. So we can make one more else if, and I'm actually just going to copy this guy and we'll paste it down here. And so I want to say if not is male and is tall. So now we're checking to see if they're male and, or if they're not male and they're tall. So here we could say you are not a male but are tall. So essentially here we have an if statement that's going to cover every single condition for these two variables. So in every single situation of the two values of these variables, we're going to be able to print something out for it. So if I made both of these true, it's basically going to tell us you are a tall male. If I make is male false, it's going to tell us you are not a male but are tall. If I made is male true and is tall false, then it's going to tell us you are a short male. And if I made both of these false, it's going to tell us you are either not male or not tall or both. And actually we need to change this. So this should say you are not a male and not tall. So that would be a better printout for that situation. So you can basically see how we can use ifs, else ifs, and else in order to help our program to make decisions and really to respond to the different data in our programs. So I'm able to respond to every combination of the values for these two variables, and that's really cool. So in this example, we were just using simple Boolean variables, but in the next tutorial, I'm going to show you guys how you can actually use something called comparison operators. So we could compare like two numbers or two strings, and we could use those as our conditions. But for now, I think this is a good introduction into if statements. So I'll see you guys in the next tutorial. In this tutorial, I want to talk to you some more about if statements in Python. More specifically, we're going to be looking at using comparisons inside of our if statements. So if you're following along with the course, in the last tutorial, I talked to you guys about just the basics of if statements, and we used a couple different Boolean variables. And depending on the values of those Booleans, we were able to do certain things. In this tutorial, we're going to look at another way to use if statements, which is with comparisons. So instead of just using Boolean values, we can actually compare different values. So like I could compare a couple numbers, or I could compare a couple strings, and depending on the results of those comparisons, we can do certain things. So this is going to be pretty cool, and this is really going to give you guys a full understanding of what you can do with if statements. So for this tutorial, I actually want to create a Python function, and this function is going to give us the maximum number that we pass into it. So this function is going to take 3 parameters as input, and it's going to print out the biggest number that we give it. So let's create this function. I'm just going to say def, and I'm just going to call it max num, and inside of these parentheses, I'm going to specify that I want 3 parameters as input. So I'm going to say num1, num2, and num3. So basically, we're passing it 3 numbers, and this function will return the largest of the 3. So in order to figure out which of these numbers is the largest, we're going to have to use an if statement. So I can say if, and over here I need to specify a condition, right? So I need to put like a true or a false value. And so what we can actually do is we can compare these different numbers. So I could say if num1 is greater than or equal to num2, and num1 is greater than or equal to num3. So basically what I'm doing here is I'm comparing these different numbers. So I'm saying if the first number is greater than or equal to the second number. And this is a comparison. So when you think about it, when we compare these two numbers, we're going to end up with a true or a false value, right? Num1 is either greater than or equal to num2, or it's not. It's actually a Boolean value, right? It's either true or it's false. Same thing over here. The result of this comparison is either true or it's false. So technically, I'm putting a true or false value in there. I'm just getting that true or false value by using a comparison. And you'll notice over here, we're using something called a comparison operator. And basically, this is just like how we want to compare them. So we're saying like greater than or equal to in this case. So down here, if this whole condition is true, in other words, if the results of these two comparisons end up being true, then we know that num1 is the biggest, so I can just return num1. I can say return num1. But we also want to check some other conditions, so I can say elif, and now I want to do some other comparisons. So I'm going to say else if num2 is greater than or equal to num1, and num2 is greater than or equal to num3. So I'm doing essentially what I did up here, except for num2. So again, I'm comparing these different numbers, and this is going to end up being a true or a false value depending on the result of the comparison. So down here again, we can just return num2, because if all of this is true, that means we're going to end up returning num2. And then finally, we can just say else. So if num1 isn't the biggest and num2 isn't the biggest, then we can pretty much assume that num3 is the biggest. So now we have our function. So down here, I'm actually just going to call this function. So I'm just going to say, actually I'll print out the result. So I'll say max num, and we'll pass in like 3, 4, 5. So we're basically calling that new function that we just made, and I'm going to go ahead and run this program. So you can see down here in the output, we printed out 5 because that was the biggest. If I was to change this middle one to the biggest, so we make the middle one 40, now it'll be able to take on that situation. And finally, I can make this like 300, and it'll be able to handle that. So no matter which number, num1, num2, or num3 ends up being the biggest, it's able to tell us without a problem. So these comparisons are a really common way to make if statements. And a lot of times, you're going to want to be comparing different values. inside of Python. So over here we're comparing numbers, but we could also compare strings. So I could easily make these both like, I could make this like dog, and I can make this dog, and I could say a different operator. So I could say like this double equal sign would mean equal. So I could basically say like if this string is equal to that string. So you can basically like compare all different data types. I could compare numbers, strings. You could also compare booleans. So once again, these are comparison operators, and this one is greater than or equal to, but there's a bunch of other comparison operators we can use. So the most basic is just going to be a double equal sign, and that basically checks to see if the two values are equal. So it'll say like if number 1 is equal to number 2. We can also say not equals, and this exclamation point will basically mean not equal. So it's if num1 is not equal to num2. We also have greater than, less than, greater than or equal to, less than or equal to. And those are kind of all of the operators, or all the, the basic comparison operators that you're going to be using in Python. So using comparisons is really awesome, and there's going to be tons and tons of situations inside of Python where you're going to want to compare different values. So these can be extremely useful. In this tutorial, I'm going to talk to you guys about building a calculator in Python. Now, if you've been following along with this course, you'll know that in the beginning of the course, we actually created a very basic calculator. Basically, the user could just enter in 2 numbers, and our calculator would add the numbers together and spit out the answer. In this tutorial, I want to show you guys how to build a more advanced calculator. So this calculator is going to be able to perform all of the basic arithmetic operations. So we can add, subtract, multiply, and divide. And we'll actually allow the user to specify which one of those they want to do. So the user will enter in a number. They'll enter in whatever operator they want to use, so plus, minus, divide, multiply. And then they'll enter in the second number, and we'll perform the operation for them. So this is going to be pretty cool, and it's going to show you how we can use if statements in like a practical application. So let's get started. The first thing we want to do is get input from the user. So I'm going to create 3 variables, one for the first number, one for the second number, and one for the operator. And we'll basically store the values that the user inputs into those variables. So the first one will just be num1. And I'm going to set this equal to input, and we're going to give this a prompt. So I'll say enter first number. And here's actually the thing is whatever the user enters, we're going to want to convert it into a number. So generally in Python, when we get input from the user, no matter what they put in, it just gets converted into a string. But we don't want a string because we're going to have to be adding or subtracting or multiplying these numbers together. So whenever they enter in the number, I just want to immediately convert it to an actual like number data type instead of a string. So what I can do is I can actually say float, and I can surround this entire input tag with parentheses. And now what this is going to do is it's going to immediately convert whatever the user inputs into a float. Now that's going to mean that they're going to have to insert a number, otherwise we'll get an error. But for the most part, this should work out for us. So I'm actually just going to copy this guy, and we'll go ahead and paste it over here, and we'll paste it one more time. So we're basically just trying to get 3 pieces of input from the user. So the second thing we want to get is the operator. So I'm just going to say OP for operator, and I'll actually get rid of this float because we want to keep this as a string, and I'll just say enter operator. So that's going to be like plus, minus, multiplication, whatever. And then finally down here we'll get num2, and again we're going to want to convert this to a float. So I'll say enter second number. So now basically what we're doing is we're getting the first number, we're getting the operator, and we're getting the second number from the user. So what we need to do now is we need to figure out what is inside of this OP. In other words, we need to figure out what operator the user was trying to do. So are they trying to do addition? Are they trying to do subtraction? Like, we want to figure that out. So we can use an if statement in order to figure that out. So I'm going to come down here, and I'm basically just going to create an if statement. So I'm going to say if, and we want to check a condition. So I'm basically going to check to see if this operator is equal to a plus sign. So I can say if OP equals plus sign. And now if the operator is equal to plus sign, I'm just going to print out num1 plus num2. But let's say that instead of a plus sign, they entered in something else. So we can say elif OP is equal to, and now we'll check if it's a minus sign. And so here we'll just print num1 minus num2. And actually I forgot to put a colon here. So we can just do these for everything. So now we can say elif OP is equal to division, and here we'll just divide the two numbers, so I can print out num1 divided by num2. And finally we'll do the same thing for multiplication. So I'll say elif OP is equal to asterisk, and we'll just print out num1 times num2. All right, so basically over here we have every condition, but I also want to put in an else statement. So in the case that the user enters in an operation that's not like one of the 4 that we specified up here, I just want to throw an error. So I'm just going to say OP, or actually we just say else, and here we'll just print out like invalid operator. All right, so this if statement should give us everything we want. Basically, I'm just checking to see if it's equal to a plus sign, a minus sign, a division sign, or a multiplication sign. And depending on which one it's equal to, we'll do a different operation. So let's go ahead and run this and see how we do. So I'm going to run this program, and it says enter first number. Let's enter 5. Enter an operator. So why don't we just do addition and enter a second number. Let's do 23. So now it prints out the answer, 28. So our calculator actually works. Let's try another operator just to make sure. So we'll do 6, and why don't we multiply it by, I don't know, 5.23. So now we go off and we do the multiplication, and looks like we got our answer. So our calculator seems to be working. And so basically all we did was we got the input from the user, and then we used if statements to figure out what they wanted to do, right? So we could check to see if they wanted addition. We could check to see if they wanted subtraction or division or multiplication. And we could also check to see if they entered in an invalid operator. So actually, why don't we try that too? So I'll enter in like 5, and now we'll just enter in like an open and closed parentheses and a 4. So you can see here it's able to tell, like the program's smart enough to know that that's not a valid operator. So these if statements can be really powerful, and we can use them in combination with getting the user input to create a little calculator. In this tutorial, I want to talk to you guys about using dictionaries in Python. Now, a dictionary is a special structure in Python which allows us to store information in what are called key value pairs. So essentially, I can just create a bunch of these different key value pairs, and then when I want to access a specific piece of information inside of the dictionary, I can just refer to it by its key. So the word dictionary is actually pretty appropriate here. If you guys are familiar with a normal dictionary, in a normal dictionary you'd have a word, and then you'd have a definition associated to that word. So in this situation, the word would be the key. In other words, the word is what like uniquely identifies it inside of the dictionary, and then the value would be the actual definition. So this is going to make more sense once we start working with this, but I just wanted to give you guys a quick introduction. So in this tutorial, I want to create a little program that will allow us to convert a 3-digit month name into the full month name. So I could convert, for example, like JAN to January, or I could convert MAR into March. Like I want to be able to have a program that can do that for us. And that's actually a pretty good use case for a dictionary. So we're actually going to create a dictionary, and I'm going to show you guys how we can do that. So the first thing we need to do in creating a dictionary is just give it a name. So I want to give this a specific name. So I'm just going to call this month conversions. And now I just want to set this equal to an open and closed curly bracket. So whenever we create a dictionary in Python, we're always going to want to create it inside of these open and closed curly brackets. And so inside of the dictionary, now we can start defining what are called key value pairs. So I can define a key and then I can give it a corresponding value. And the way that we can do that is just by typing out the key and then typing out the value. So in our case, we're converting 3-digit month names into the full month names. So I would want to type out, for example, JAN, and then I can type a colon, and I want to type out the value I want to associate with it. So we could say January. I could basically do this for every combination. So I could say like FEB, and this would be February. And actually, after each one of these, we're going to need to put a comma. So I could do the same for March. So we'd say MAR. So essentially what I can do is I can specify an entry inside of this dictionary for each one of these. So this over here would be the key, and this over here would be the value. And here's one thing is all of these keys have to be unique. So if I was to come down here and change this to JAN, this is actually going to give us a little warning. So you can see down here it says dictionary contains duplicate keys. That's a no-no when we're creating dictionaries. So you always want to make sure that the keys are unique. All right, so I'm going to go ahead and create one of these for each one of the months, and then we'll come back and we'll talk about it. All right, so I've gone ahead and created an entry for all 12 of the months. So now we have a bunch of unique keys, and each one of those keys is associated with a different value. So this is the basics of creating a dictionary. Is we have a bunch of these different key value pairs, and now what we can actually do is we can access them from inside of this dictionary. So if I wanted to access a specific key or a specific value, all I have to do is come over here, and I'm actually just going to print it out onto the screen so we can see it. All I have to do is refer to the dictionary by name, so it's just called month conversions. And there's actually a bunch of different ways that I can access these month names. So I could access different entries inside of this dictionary. The first way is just by making a open and close square bracket, and inside here I can just type in one of the keys. So for example, inside here I could type in NOV, and what this should do is it should give us back the full name for November. So when I print this out, you'll see that we get back down here November. So I could do the same thing for any of these. We could say like MAR, and now we should get March back. So I'm able to refer to the key, and it's going to go into the dictionary, and it's going to give me the value that's associated to that key. There's actually another way we could do this too. So I could say month conversions dot get, and inside of here I could also pass in the name of the key. So I could pass in like DEC, and now we'll be printing out December. And what's cool about using this get function is I can actually specify a default value that I want to use if this key is not found. So there's going to be certain cases when we're dealing with dictionaries where you're going to put in a key that might not necessarily map to a value inside of the dictionary. So you'd put in an invalid key. So let's just try to do that. So I'll just put like LUV. That's not a month abbreviation. So when I try to run this, you'll see we get this none down here. And in a lot of cases, you're going to want to create some sort of a default value. So if I'm in this situation where I have a key that's not mappable to any values inside of this dictionary, I can actually pass it a default value. So inside this .get function, I can make a comma, and now I can pass in like a default value to get printed out. So I can say like not a valid key. And now when I put in the invalid key, instead of saying none, it's going to go ahead and say not a valid key. So this is going to give us like a default value that we can fall back on. So these dictionaries are really awesome, and the keys over here don't have to be strings. So you could also use numbers. So for example, I could say like 0, 1, 10. Like I can put any numbers I want over here as keys as long as they're unique. And then I could access those keys just like I normally would down here with this get function or with those open and closed square brackets. So that's sort of the basics of using dictionaries. They can be really useful to store key value pairs. And honestly, you're going to be using them a lot in Python to store different types of data. In this tutorial, I want to talk to you guys about while loops in Python. Now, a while loop is basically a structure in Python which allows us to loop through and execute a block of code multiple times. So I could specify like a few different lines of code, and then I could put that code inside of a while loop, and it would basically loop through that code, executing it repeatedly until a certain condition was false. So while loops can be awesome, and there's a lot of situations in Python where we're going to want to loop through specific lines of code. So in this tutorial, I just want to show you guys the bare basics of how while loops work. And then in future tutorials, we're going to use while loops to create little games and stuff like that. So let's talk about while loops. When I create my while loop, the first thing I want to do actually is create an integer. I'm basically creating a variable that's a number, and you don't have to do this for a while loop, but just for our demonstration, I'm going to. So I'm just going to call this I, and I'm going to set it equal to 1. And now what I want to do is I want to create a while loop. So I'm basically just going to say while, and over here I want to specify a condition. And this is what's called our loop condition, or you can also refer to it as a loop guard. And basically, we are going to keep looping through the code inside of the while loop as long as this condition is true. So whatever condition I put in here, as long as it's true, we're going to keep looping through the code inside the while loop. So I'm just going to say while I is less than or equal to 10. And now I'm going to put a colon, and I'm going to make a new line. And so anything that's below this while loop declaration and that's indented like this is going to be considered code that's inside the while loop. And so that code is going to get repeatedly executed while this condition up here is true. So I'm just going to put a very simple line of code here. We're just going to print out the value of I. And then down here, I'm going to actually increment I. So I'm going to add 1 to I. So I'm going to say I is equal to I plus 1. So basically, I'm taking this I value and I'm adding 1 to it. There's actually a shorthand that we can use in Python to do something like this, though. I could just say I plus equals 1, and that's automatically going to add 1 to I. So this is like a little shorthand, and you'll see people in Python using that a lot. So over here, we basically have our while loop. So I have the outline for a while loop. So we're defining this variable up here, and we're going to keep looping through the code inside the while loop as long as this condition up here is true. So if this condition is false, for example, if I is equal to 11, then we're not going to loop through this code anymore, and we're just going to move on. So down here, I'm actually just going to print done with loop. So this will kind of illustrate this for us. All right, so let's go ahead and run this program. I'm just going to run it, and you'll see down here we get some output. So we're actually going to get numbers printed out 1 all the way down through 10, and then we're printing out done with loop. So basically what's happening is we're printing out every time we go through this loop. So initially I is equal to 1, right? The first thing that Python's going to do when it gets to this while loop is it's going to check this condition. So before it does anything else, it's going to check this condition, and it's going to say, okay, is 1 less than or equal to 10? And that's true. So as long as this guy is true, we're going to go through and loop through all the code inside of here. So we're going to print out I, which has the value of 1, and then we're going to add 1 to I. So now I is going to go from 1 to 2. Now what we're going to do is we're going to go all the way back up here to this while loop declaration, and we're going to check the condition again. So remember, I checked the condition the first time, and then I looped through all the code. Then I go back up to the top, and I check it again. So I'm going to say, okay, is I less than or equal to 10? At this point, I is equal to 2. So I is less than or equal to 10. So now we're going to go through, and we'll execute all this code again. So I'm going to print out I, so it's going to be 2. And I'm going to add 1 to I, so now we have 3. Then Python's going to go all the way back up to the top, and it's going to check the condition again. So on every iteration through the loop, before Python does what's inside of this loop, it's going to check that condition. And as long as the condition remains true, we're going to keep executing the code inside the loop. Eventually, though, in this program, I is going to end up being 11, right? So on the last iteration, it's going to end up being 11. We're going to come back up here, and we're going to say, is 11 less than or equal to 10? Nope. And so since it's nope, we're going to come down here and we'll print out this done with loop line. So that's the basics of how these while loops work. We're specifying a loop condition. As long as that condition's true, we'll keep executing the code inside of the loop. And after every execution of the loop, we're going to come back up and check the condition again. So that's how we end up with this printing out down here. So that's the basics of a while loop. And we can use these while loops to do all sorts of things. Like, while loops are very, very powerful. In this tutorial, I'm going to show you guys how to build a basic guessing game in Python. And in this guessing game, we're actually going to be using all sorts of cool programming structures that we've learned up to this point in the course. So we're going to be using things like if statements and while loops and variables and all these cool things in order to build this game. So the basic idea is we will specify like a secret word. So we'll have a secret word that we store inside of our program, and then the user can interact with the program and try to guess the secret word. And so what we want to be able to happen is we want the user to be able to keep guessing what the secret word is and keep typing in different responses until they get the secret word right. So that's the basics of what this game is going to be. And now let's go ahead and create it. So the first thing we want to do is create a variable to store our secret word. So I could say secret word, and we're just going to set this equal to a secret word. So why don't we make it giraffe? That's a pretty good secret word. And now what we want to do is we want to create a variable that will store the user's response. So I want a variable that will store like all the guesses that the user makes. So I'm just going to call this guess. And I'm just going to set it equal to an empty string right now. So now we have the secret word and we have a variable to store the user's guess. And what we need to do is we need to be able to prompt the user to input the secret word. But here's the catch. What we want to happen is we want them to enter the secret word, and if they don't guess it correctly, we want to prompt them to enter it again. And so we can't just use a single input statement. We actually have to use something called a while loop. And we can use a while loop in order to continually ask the person to guess the word until they guess it correctly. So let's go ahead and create our while loop. So I'm going to say while, and after I say while, I need to specify a looping condition or a looping guard. Basically, this is something that as long as it's true, we're going to keep looping through this loop. So basically, I want to keep looping as long as the user's guess is not equal to the secret word. So as long as they haven't guessed the secret word, I'm going to keep going through this loop. And inside of this loop, what we're going to do is we're going to ask them to input the secret word. So I can take this guess variable and I can set it equal to input, and I'm just going to say enter guess. And so over here, we're basically telling the user to enter in their guess. I'm storing whatever they enter inside of this guess variable. And then what's going to happen is we're going to come back up here. We're going to check to see if the guess is equal to the secret word. If the guess isn't equal to the secret word, then we're going to do it again. But if the guess is equal to the secret word, then we're just going to break out of this loop. And so we can come down here and we can just print out a success message. So I could say, you win, because they got the secret word. So this is a very, very simple program, but this is essentially all of the code that we need to be able to build a game like this. So let's go ahead and play our game. We can run it and see how we did. So I'm going to click play. And down here you can see it's prompting us to enter a guess. So I'm just going to type in some random text. We can type in whatever we want. And as long as we're not entering that secret word, it's going to keep prompting us to enter different information. But if I enter in the secret word, so if I enter in giraffe, now all of a sudden the program's going to terminate and it's going to say, hey, you win, because we were able to guess the secret word. So that's like a really cool way for us to be able to do this. And we actually have a fully functional guessing game. But I think this guessing game could actually be improved quite a bit. A lot of times when we're making a guessing game, we want to set a limit. So in other words, I want to set a limit for the number of times that the user can try to guess the word. So let's say that the user has 3 tries, right? They have 3 guesses in order to guess the word. And if they can't guess the word after 3 tries, then they're going to lose the game. But if they can guess the word inside of 3 tries, then they'll win the game, right? I think that would be a little bit more of a fun game. So why don't we try to program that game? Basically, we're going to set a limit on the number of guesses that the user can have. In order to do this, we're going to have to create a couple more variables down here. In other words, we're going to have to store a couple more pieces of information. The first piece of information I want to keep track of is how many times the user has guessed, right? So we can just make a variable called guess count, and we'll just set this equal to 0 because initially the user won't have guessed. Down in this while loop, every time we go through the loop, I want to increment that guess count, right? So every time we've gone through this while loop, I want to increment that count because that means the user will have guessed. So down here, I'm going to say guess count plus equals 1. And this is just going to add 1 to the guess count. Actually, whoops. All right, so after each iteration of this loop, we're going to go ahead and add 1 to the guess count. All right, so that's the first variable that we're going to need. We're also going to want to store another variable, and this is going to be called guess limit. And basically, this is going to tell us how many times the user can guess the word. So it's going to be guess limit, and we'll basically just say 3. So let's say that the user has 3 tries to guess the word, 3 strikes, and you're out. So the user, if they can't get it in 3 tries, then we're going to basically say that they lose the game. And I'm also going to need one more variable here, which we're going to call out of guesses. And I'm just going to set this equal to false initially. So this out of guesses variable is going to be a Boolean, and it's going to tell us whether or not the user is out of guesses. So if out of guesses is true, that means they have no more guesses, right? They basically lost the game. And if out of guesses is false, that means that they still have some guesses left, so they can keep playing. All right, so let's use these different variables in order to make our program more functional. So the first thing I want to do is when I go through this loop, I want to check to make sure that the user has more guesses, right? In other words, before I let the user enter a guess, I want to check to see that they haven't already used up all their guesses. So down here, I can make an if statement. I can say if, and inside of the condition, I want to check to see that guess count is less than guess limit. If guess count is less than guess limit, that means that they haven't guessed the total number of guesses that they have, so they have some guesses left. And if that's the case, and if that's true, then I'm going to go ahead and give them a guess, and then we'll increment the guess count. If this isn't true, in other words, if they have reached their guess limit, then I'm going to want to set out of guesses equal to true. Because they're out of guesses, right? They have no more guesses because the guess count wasn't less than the guess limit. And so that means that they're out of guesses, so they have no more guesses. So there's actually one more thing we need to do inside of this while loop. We need to add another condition onto this loop guard. So right now, we're going to keep looping as long as the guess is not equal to the secret word. But remember, if the user's out of guesses, in other words, if they've reached their guess limit, we don't want them to guess anymore, right? So if they ran out of guesses, then we want to basically break out of this loop and not give them any more guesses. So I'm going to go ahead and add another condition onto here. And I'm going to say, while they haven't guessed the secret word and they're not out of guesses, so it's going to be not out of guesses, then we're going to keep looping. So as long as they haven't guessed the word and as long as they still have some guesses left, we're going to keep looping. But otherwise, we're going to break out of the loop. And so down here, we're printing out you win. But actually, when we break out of this loop, there's going to be two possible scenarios. So again, there's two possible ways that this loop could end, right? Either the guess is equal to the secret word, so either the user guessed the word correctly, or the user ran out of guesses. And so there's two situations down here that we need to account for. And so I'm going to use an if statement to figure out which is which. So I'm going to say if, and we're just going to type out of guesses. And if the user is out of guesses, then I want to print out of you lose. So we're basically going to be like, you lost the game. Otherwise, though, if they're not out of guesses, that means that they guessed the word correctly. So we're just going to print out you win. All right, so now we have all of the logic for this little guessing game set up, and let's see if we can run it and play through it. So I'm just going to run this program, and now it's going to tell us to enter a guess. So why don't we enter more guesses than we have? So we're going to try to lose the game. So I'm just going to enter one guess, two guesses, and now I'm on my final guess. So if I don't get it here, we should actually lose the game. And you can see it says, out of guesses, you lose. So we weren't able to guess it in the number of tries that we had. Let's run the program again, and we'll try to win the game. So we'll get a couple wrong. Let's say we're on our last guess, and I'm like, okay, I can do this. So I type in the word, and bam, we won the game. So that's how we can basically create a game where we have a guess limit. So this is a lot of code. Let me walk you guys through this one more time so you can just get a full understanding of what we're doing. Up here, I created a few different variables. We created this secret word variable, and we created this guess variable. Then we also created some more variables. So we created this guess count variable. And this just keeps track of how many times the user has guessed the word. And you can see down here, every time we give them a guess, we're incrementing the guess count. We also have guess limit. And guess limit is telling the program how many times the user can guess. So before I go through this while loop, the first thing I'm doing is I'm checking to see that the guess count is less than the guess limit. In other words, do they still have some guesses left? If they do, then we're going to get the input from the user. Otherwise, we have this other variable up here called out of guesses. And out of guesses is going to tell us whether or not they have some guesses left. So if this is equal to false, that means they have some guesses. If it's equal to true, however, it means no more dice, no more guesses, they are done. So they lost the game. The last thing we needed to do was specify an additional condition up here. So we are going to keep looping through the code inside of this loop as long as the conditions up here are true. So as long as they haven't guessed the word, and as long as they're not out of guesses, we are going to keep looping through. And so when eventually the user does break out of this loop, there's going to be two possible situations. The first situation is that they ran out of guesses. And so we want to check to see if that's the situation. I want to check to see if they're out of guesses. If they are, we'll print out a lose message. If they're not, then they must have guessed it correctly, so they win. And so that is how we can use while loops and if statements and also variables in combination with each other to build a pretty awesome guessing game. In this tutorial, I want to talk to you guys about using for loops in Python. Now, a for loop is a special type of loop in Python which allows us to loop over different collections of items. So a lot of times we'll use for loops in Python to like loop through different arrays, or we could loop over like the letters inside of a string, or we could just loop through like a series of numbers. So for loops provide a very specific purpose, and the easiest way to kind of wrap your head around why for loops are useful is just for me to show you guys a bunch of different examples. So that's exactly what I'm going to do. We're going to look at why for loops are awesome. So down here in my text file and my Python file, I'm going to write out a couple different for loops. So the way that we create a for loop is just by saying for, and now what I want to do is specify a variable. And this variable is going to essentially represent a different value every time we go through this for loop. And you guys will see how that works in a second. But just know that this variable is going to be used on every iteration of our for loop. And each time it will most likely have a different value. So in our case, I'm just going to call this letter. And I'm going to say for letter in. And now what I want to do is I want to specify a collection that I want to loop over. One example of this would be like a string. So I could put a string in here. I could just put like Draft Academy. And now I can just put a colon. And so basically what this is going to say is it's going to say for every letter inside of Draft Academy, I want to do something. And so down here inside of this for loop, and again, we need to indent this, we can put what we want to do with each letter. So let me just show you guys like basically what this is going to do. So I can print out letter. So I can print out this letter variable, and it's actually going to print out a different letter inside of this Draft Academy string on every single iteration of this loop. So I'm going to run this program, and down here inside of my console, you'll see that I'm basically printing out Draft Academy. So on the first iteration of the loop, I printed out the first letter in Draft Academy, which was G. On the second iteration of the loop, I printed out I, third was R, fourth was A. So I'm essentially just looping through all of the letters inside of Draft Academy. So I'm saying for each letter in Draft Academy, I want to print out that letter. And so this is kind of like how for loops can be used. We can define a variable, and that variable will change on each iteration of the loop, right? So on the first iteration of the loop, this letter variable represented a G. On the second iteration of the loop, the letter variable stored the value I, etc. Right? So we went through this entire string and we were able to print out each letter. So in addition to using this with strings, we can also use this with other collections, for example, like an array. So if I created an array up here, let's just call it friends, I'm going to set this equal to a bunch of different values. So we can put like a list of our friends in here. We can say like Jim, Karen, and Kevin. Instead of saying letter, why don't we call this friend? And I could say for friend in friends. And now we'll print out the friend. So over here, I'm saying for each friend inside of this friends array, I want to print out the friend. So now we'll actually be able to print out each element inside of that array. So down here, you'll see we're printing out Jim. And then on the second iteration, we're printing out Karen, and on the third, we're printing out Kevin. So I'm able to loop through all of the values inside of the array. And just so you guys know, like, you can name this variable whatever you want. So I could give this like any random name. And if I want to access it though, I have to access it using that same name. So we can loop through something like an array. We could also just loop through a series of numbers. So I could say index over here. And again, this can be anything. I'm just going to call it index. So we could say for index in range, and then in here I can pass in a number. So I could pass in like 10, for example. And down here, I'm just going to print out the index. When I run this program, you guys will see that it's basically going to print out every number in the range from 0 to 10, not including 10. So starting with 0, it's going to print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But notice that it didn't print out 10. So it's essentially just printing out all the numbers between 0 and 10, not including 10. You can also specify a range of numbers. So I could say, for example, like 3 and 10. And now this will print out all the numbers between 3 and 10, not including 10. So we'll run this program. And you can see we print out 3, 4, 5, 6, 7, 8, 9, and not 10. So whatever value that you put here in this second position is not going to get included in the range. And ranges can be really useful. So for example, I could use a range to loop through an array just like we did before. So if I wanted, I could say something like for index in range, and now inside of this range, I can pass in the length of the array. So just so you guys know, if I wanted to get the length of this array, in other words, if I wanted to figure out how many elements were inside of it, I could just type out len and then inside parentheses, the name of the array. And so this is gonna spit out 3 because there's 3 elements inside of here, right? Kind of makes sense. So what I can do is I can say down here inside of this range function, I can just type in len and then friends. And so what this is gonna do is it's gonna essentially give me a range between 0 and the number of friends inside of this list. So down here I could actually type out friends index, and this will allow me to access each individual friend inside of this list, just like we did before, but now I'm doing it with a range. So you can see I'm typing out Jim, Karen, and Kevin. So actually, for each iteration through this loop, it's basically going to be printing out friends 0, friends 1, and then friends 2, because in here we're passing in a 3. And remember, whatever I pass in there, it's going to range from 0 all the way up to that number, but not including that number. So that's another way that we could print out all the elements in the array. And looping through something like an array is actually a very, very common use case for loops. But like I said, we can use for loops to loop through essentially any collection that we have. So we could loop through like a string. We could also loop through, something like an array. So this can be really useful, and that's sort of the basics of for loops in Python. And I also want to show you guys one more example just while we're here. So why don't we go ahead and print out a range up to 5, right? So this will just be a simple program. You can use all sorts of logic inside of these for loops. So let's say that I wanted to do something special on the first iteration of the loop. So I could say if index is equal to 0, and if the index is 0, then we know it's the first iteration of the loop. So I could do something special. I could like print out first iteration, and then otherwise we could just print like not first. So this would be an example of like maybe you want to do something on the first iteration of the loop and do something else on subsequent iterations. So if I play this, you'll see only on the first iteration is it printing this out, and otherwise it's printing out other stuff. So don't be afraid to put some complex logic inside of these for loops, because it can really make your programs more powerful. In this tutorial, I'm going to show you guys how to build an exponent function. Now, an exponent function is basically going to allow us to take a certain number and raise it to a specific power. So in Python, there's actually a really easy way to do this. I could come down here and I could print, we could say like 2, and we can just do 2 multiplication signs, and I could say 3, and this is basically just going to be 2 raised to the 3rd power. So you can see here, I can just print this out and we get 8 because that's 2 cubed. So it's really easy to do exponents in Python, but I want to show you guys how we can use something like a for loop in order to create a function like this of our own. So we'll actually create an exponent function that will basically do this, and we'll use for loops to do it. So let's create a function. So I'm just going to say def, and now we need to give this function a name. So why don't we call it raise to power? And inside of here, I'm going to accept 2 parameters. The first parameter is going to be the base number, and then the second parameter is going to be the power number. So we're going to take the base number and raise it to the power number. So over here, we can just make a colon. Now, inside of this function, we need to start writing some code. Here's the thing. Inside the function, we don't necessarily know the value of this pownum, right? For example, if we knew that we were just trying to like square this number or cube this number, I could just return like base num times base num, right? That would square the number, or I could cube the number base num. So this would be like the number cubed. The problem is though, we don't know like right off the bat what this value is going to be, right? This could change, like the user can decide that. So in order to write this function, we're actually going to need to use a for loop. And I'm going to show you guys how we can use a for loop to basically figure this out. So the first thing I want to do is create a variable, and I'm just going to call it result. And we're just going to set result equal to 1. So we're going to start this off at 1. Now I want to create a for loop. So I'm basically just going to say for, and over here, I basically want to specify like a index. So I'm going to say index and now I want to specify a range. And a range will basically range us through a collection of numbers. So basically I want to multiply the base num by itself as many times as the pownum specifies, right? So over here I can just make this a range of pownum, right? And so we'll basically loop through this for loop as many times as pownum. So if pownum is 2, we'll loop through it twice. If pownum is 4, we'll loop through it 4 times. And every time through the loop, we'll multiply base num by itself. Or actually, you'll see we're going to multiply it by this result. And so down here inside of this for loop, I can basically say result is equal to result times base num. This should actually give us everything we need to take this number to the specific power. So the actual result, of doing the math is going to get stored inside of this result variable. So the first time through the loop, we're just multiplying base num by 1, right? And so now result is going to become the same value as base num. The second time through the loop, so this would be if we were squaring the number, we're basically multiplying result by base num again. So it's essentially just base num times base num. The third time through the loop, we're multiplying result times base num. So we're essentially just cubing the number. So that's essentially what this for loop is doing for us. So the last thing I want to do is right here below this for loop, I'm just going to return the result. So we'll be able to return whatever the result of raising the number to the power was. All right, so let's come down after this function and we're just going to call it. So I'm just going to say, actually we'll print out the answer. So I'm going to say raise to power. And inside of these parentheses, remember we can pass 2 numbers. So let's raise 3 to the second power. So we're just going to square 3 and we'll see how this works. So let's run the program. And you can see down here in the console, we're getting 9. Let's try something a little bit crazier. Let's try 3 to the 4th power. And we'll run this and we get 81. So that's 3 to the 4th power. Let's try 2 to the 3rd power. And we're getting 8. Yeah, so that makes sense. So our raise to power function is working just as expected. And I'll just walk you guys through it one more time. So inside of this function, we're taking in 2 pieces of input. We're taking in a base number and we're taking in a pow number. So that's the base number is going to be taken to the power number. I'm defining a variable here called result. And result is where we're going to store the actual result of doing the math. Now we specify this for loop. And I'm basically saying that I want to loop through this range of numbers. When I put pownum here, it's basically going to range from 0 all the way up to, but not including the power number. So we'll basically loop through power number of times, if that makes sense. And then every time through the loop, we're just multiplying result by base num. And then we're just returning result. So that's the basics of building a power function. And obviously, if you're just trying to take a number to a power in Python, it's really easy. But this kind of shows you the internal workings, right? For a function like that to work, we would have to actually type something out just like this. In this tutorial, I want to talk to you guys about 2 different concepts in Python. It's going to be a pretty cool lesson. First thing I want to show you guys, though, are 2-dimensional lists. So down here in our Python file, I just want to create a basic list. So I'm just going to call this number grid. And I'm just going to set this equal to a normal list, right? Just like this. Now, normally, if we were creating a list, I could just put in a bunch of attributes and a bunch of elements, right? And now all of these elements are inside of this number grid list. Everybody's happy. But another thing I can do is I can make all of the elements inside of this number grid list lists. So the first item in the number grid list is going to be a list. The second item in the number grid list is going to be a list, etc. So I'm going to show you guys how to do that. I can basically just come down here and where I would normally put the first element in the list, I can just create another array. So I'm just going to make an open and closed square bracket. And now I'm just going to say 1, 2, 3. And I can create the next item in my list. I can say 4, 5, 6. And let's make another item in this list. I can say 7, 8, 9. And finally, we're going to put one more list inside of the number grid list, and it's just going to have 0 in it. So inside of this number grid list, right, this high-level overall list, we have 4 elements. And all of those elements are themselves lists. So essentially what we're doing is we're creating a grid, right? This grid has 1, 2, 3, 4 rows and 1, 2, 3 columns, right? 4 rows, 3 columns. And that's kind of like why these can be useful, is we can create a grid-like structure inside of Python using 2-dimensional lists. So this is a pretty cool list structure, and I want to show you guys how I can access individual elements inside of this list structure. So for example, let's say I wanted to print out one of these values. Let's say I wanted to print out this 1 right here. The way I can access it is by saying number grid. And the first thing I want to do is make an open and close square brackets. And in here, I want to put the index of the row that I want to access. So this would be like row 0, because that's the 0th element in the array. This would be row 1, it's at index position 1. This would be row 2, row 3, etc. So I could put row 0. And now, right next to this, I'm going to make another square bracket. And I want to put the index of the column. So this would be like column 1, column 2, column 3. So I'm going to put another 0 because this is at the 0th index of this first array. So I just put 0, 0 here. Now we can print this guy out to the screen, and you'll see down here that we get that 1. So I could also do this for this 8, for example. So this is going to be 0, 1, 2. It's going to be row 2 and column 1. And now we should be able to print out that 8. So that's basically how we can access elements inside of this 2D list. The next thing I want to show you guys is a nested for loop. A nested for loop is a situation, like I said, where we have a for loop inside of a for loop. And I'll show you how we can use this nested for loop in order to print out all the elements inside of this array. So I'll basically show you guys how to parse through a 2-dimensional list or a 2-dimensional array. All right, so basically we're just going to create a normal for loop. So I'm going to say for, and I'm just going to say row in number grid. And I'm using the word row here because I'm kind of seeing these guys as rows, right? These are sort of horizontal rows in our little grid. So for each of those rows, for each of the elements inside of number grid, I want to loop through. So I could actually just print out each row right now, and it's just going to print out all the rows inside of this list. So you can see down here, we basically just get exactly what we have up there. But I want to be able to access each of these individual attributes inside of each of these array elements. So we can actually create another for loop, and I'm going to put that for loop inside of here. So now I'm going to say for column in row. And basically what this is going to give us is each individual column or each individual element inside of these arrays. So for example, inside of the arrays that are the elements of the number grid. Hopefully that makes sense. So down here, now I can just print out column, and this should actually print out every single value inside of this 2-dimensional array. So let's go ahead and run this program. And down here you'll see that we're basically printing out 1 all the way down to 0. So we're printing out all of the elements inside of all of the arrays inside of the number grid. So that's how we can use 2-dimensional lists and nested for loops together. And both of those things are actually pretty handy in Python. In this tutorial, I'm going to show you how to build a basic translator in Python. So essentially we can take in a string, so we can take in like a phrase or a word, and we'll be able to translate it into a different language. So over here I have this little file, and it basically specifies this language that I made up. So I'm calling it the draft language. And in the draft language, all vowels become G. So if I was going to translate an English word into a draft word, for example, the word dog, I would look through the word dog and any instances where there was a vowel, so in our case, let's just say A, E, I, O, or U, I would convert that vowel into a G. So dog would map to DGG, cat would get mapped into CGT. So those are the basic translation rules. Obviously this is a pretty simple language, but you get the point. Any vowel is going to become a G, and then we'll get the draft language. So we're going to build a draft translator. Over here in our Python file, let's start making this translator. The first thing I'm going to do is just define a translate function. So I'm going to make a function here, and I'm just going to call it translate. And inside of these parentheses, we want this to take one piece of information, which is going to be the phrase that we want to translate. So I'm just going to say phrase. And now inside of this function, we need to figure out, like, okay, how can we translate English into our draft language? Well, remember, the rules is basically just any vowels become G's. So the first thing I want to do is create a variable. And this variable is going to be the translation. So this will be like the final result that we're going to return to the user. So I can say translation. For now, I'm just going to set it equal to the empty string. So this is just going to be like a completely empty string. It's not going to be doing anything. And now what we want to do is we basically want to loop through every letter inside of this phrase, and if it's a vowel, we want to change it to G, and if it's not a vowel, we want to leave it alone. And we're essentially going to be looping through phrase, and we're going to be adding the letters onto this translation one by one. So let me show you guys how we can do this. I'm going to make a for loop, so I'm going to say for, and I'm just going to say letter in phrase. And so now, when I loop through here, I can access each individual letter inside of the phrase that they passed in. So what I want to do is I want to check to see if the letter is a vowel or not, right? If it's a vowel, then we can add a G onto translation. If it's not a vowel, then we can just add on whatever letter it was onto translation anyway. So I'm going to use this if statement. I'm going to say if. And there's actually this special thing we can do in Python. We can check to see if something is in something else. So I can say if letter in, and over here I'm just going to type out all the vowels. So we'll say A, E, I, O, U, and A, E, I, O, U. So I'm basically checking to see if the letter is inside of this string. And if the letter is inside of here, then we know that it's a vowel. So down here, we can handle that case. So I can say translation is equal to translation plus G. Because if this letter is a vowel, we just want to convert it into a G. Otherwise, though, I can basically just say translation is equal to translation plus letter. So in the case where we have a vowel, I'm adding a G onto translation. In the case where we don't have a vowel, I'm just adding on whatever letter it was onto translation. So finally, down below this for loop, we just want to return the translation. So I'm just going to say return translation. And now we have a awesome translate function, and it should probably work. So let's come down here and we'll test it out. So why don't we allow a user to input some information? So I'm basically going to call this function. Actually, we're going to print it out. So we'll print this out, and I'm going to call this function translate. And inside of here, I'm actually just going to pass whatever the user inputs. So I can just say input, and inside of these parentheses, I can say the prompt. So enter a phrase. And so now I'm basically combining all of these statements together. I'm saying I want to print out the translation of whatever the user enters in. So let's go ahead and run this program, and we'll see how we do. So I'm going to run the program. It says enter a phrase. Actually, let me format this a little bit better. Okay. All right, so it says enter a phrase. So let's go ahead and do that. So let's just type in the example we used before. I'm going to say dog. And so now out pops the answer, which is DGG. So that's kind of cool. And then we can just keep running this as many times as we want. So I could type in like to be or not to be. So this is like a little bit longer of a string. And you can see it translates it into our draft language. So that's basically how we can create our little translator app. And that's pretty cool. And so you can see we're using a for loop in combination with an if loop, and that's a really powerful structure. And actually there's one place over here where we can make this a little bit more efficient. So instead of saying if letter in this string, you'll notice here I'm checking to see if it's in all the lowercase and the uppercase. I could actually just say if letter dot lower in, and now I only have to type out the lowercase letters, and it's still going to do the same exact thing. So that's a little like hack or whatever that we could use. And there's also one more problem with this program. So you'll notice down here, we're setting the translation equal to the translation plus G. But the problem is, if I was to start my word inside of the phrase with a capital vowel, so in other words, if I said like on, you'll notice that when this gets printed out, it gets printed out as lowercase gn. So it's not keeping our uppercase syntax. And that's kind of a problem. So we could actually use another if statement in here, and we could check to see if letter dot is upper. And if the letter is uppercase, then we can just set the translation equal to the translation plus a capital G. Otherwise, we can just set it equal to the lowercase g. And so now we're able to control both of those situations. So let's just test this and see if it works. Enter a phrase, say on, and now we're keeping that capital letter. So those are just a couple different ways that we could make this program a little bit better. But the basic concept is we have a for loop, and then we have some if loops inside of it, and we're calling this awesome function that can translate a word for us. In this tutorial, I want to talk to you guys about comments in Python. This is going to be a pretty short tutorial. I just want to give you guys an overview of what comments are and how we can use them in our Python programs. So over here in my Python program, I just have this line here. It says print comments are fun. So if I run my program down here inside of the console, it's going to print out comments are fun, right? So any code that I put over here is going to get executed by Python. But there's actually a special line of code that we can write, and it's called a comment. And a comment is basically a line inside of our Python file that's just not going to get rendered by Python. So when Python sees it, it's just going to ignore it. It's not going to execute it. It's not going to print anything out. It's just going to kind of ignore it. And comments are basically just used for us humans. So a comment is used for like me or another developer to write a little comment, a little like plain text, comment inside of a file. So in order to create a comment, I could use this hashtag symbol. So I can click hashtag, and now I am writing a comment. So I can write whatever I wanted in here. I could say like, this program is cool. And you'll notice when I run the program, that doesn't show up anywhere, right? It doesn't matter what I put after this hashtag. This is just like ignored by Python. It's just for me or another developer to come in here and use. So a lot of times if you want to write like a little note inside of your Python files, or maybe you can write yourself a little reminder, or if you want to write a line to like explain a line of code. So for example, I could write a comment that would explain this print statement. So I could say like, this prints out a string, right? Now anybody looking at my file would be able to read this and they'd be like, oh, that's what this does. Okay, cool. So comments are useful for leaving little comments in a Python file. If you want to make comments on multiple lines, you can just create a new line and use another hashtag. And so then I could type out whatever my next comment was. And generally, if you're going to put comments on multiple lines, you want to just use multiple hashtags. But there's actually another way that you can write out comments. So you can use a triple quotation mark. So I'm typing out the single quote, and I'm typing it out 3 times. So you can see here, up here we have this 3 times, we have this 3 times. So in here I can, write any comment that I wanted. So I could put, as much text up here as I would want. And same thing, when I run this program, it's just not going to get rendered. So this is another way to make multiple line comments. But the official Python style guides or whatever just recommends that if you're going to put comments on multiple lines, you use these hashtags. So you can really do whatever you want, but if you want to be super Python official, then use these hashtags. Comments can also be useful for doing something called commenting out a line of code. A lot of times when you're writing a program, you might have a line of code in there that is maybe potentially messing stuff up. And so what you can do is you can actually comment out that line of code. So I could put a comment in front of this line of code, and now when I run my program, the program's going to run, but it's not going to use this line. So sometimes if you're trying to see if like a line of code is causing you trouble, or if you want to see what your program would be like without a line of code, or even like a block of code, you can just comment it out. And that way you're not actually deleting the code from your file, you're just commenting it out, so Python's going to ignore it. And those are really the two uses for comments. It's to write little notes, write little comments about different things, or to comment out code. And as you go forward in Python, I'm sure you'll find uses for comments. In this tutorial, I want to talk to you guys about catching errors in Python. Now, a lot of times when we're writing Python programs, you'll encounter different errors. So different situations could come up and your program might throw an error or it might throw an exception. And a lot of times when these situations happen, they'll completely stop your program from running. And what we can actually do is we can watch out for, certain specific errors that are going to pop up in our program, and we can actually handle them. So instead of our program just breaking and stop executing, we can actually handle those errors and do things when they occur. So I want to show you guys an example of using this. Down here I'm saying number is equal to int, input, enter a number. Basically what's happening is I'm prompting the user to enter in a number using this input command, and then I'm converting whatever they entered into an integer. So as long as they enter in like a valid integer, I can convert it into an integer. So I can convert it into like a whole number, and I can store it inside of this number variable. Then I'm just printing it out. So let's try to execute this program. I'm going to run the program, and you'll see down here it says enter a number. So we can enter in like 4, for example. And when I enter in 4, everything's going to work, and it's just going to print out 4, and everything is right in the world. And actually, I'm going to modify this up here so it's a little easier to see. But let's say we run the program again. So it says, okay, enter your number. Let's say that I break the rules and I don't enter a number. So I just ignore what the prompt says and I put, some random text in here. Now when I enter this, the program's going to throw an error. You can see down here it says value error, invalid literal for int base with base 10. Basically, hey, you didn't enter in an integer like you said you would, right? We told them to enter in a number, they entered in text, so it broke the program. And this is a situation that happens a lot. So there's a lot of different situations where something can just go wrong in our program. And up until now, we've just kind of accepted it as a reality. But if you're writing a real live Python program, you don't want something like this to trip up your program. You don't want the entire program to break when somebody just forgets to enter in a number, right? You want to be able to handle all these different situations. And in order to handle them, we can use something called a try except block. And a try except block will basically allow your program to try out a piece of code, and if everything goes well, then we're great. Like, we could try out entering in the number, and if the user enters in the correct number, great. But if they don't enter in the correct number, then we can basically like account for that. So if they entered in something like a string when they're supposed to enter in a number, we could tell them like, hey, you entered in the wrong thing. So I'm going to show you guys how we can use these try except blocks. I'm going to come up here, and I'm just going to say try. I'm going to make a colon, and now I want to indent both of these things. So both of these things are going to be inside of this try block. Now I'm going to make a new line. I'm going to come down here, and I'm just going to type out except. And I'm also going to put a colon here. And down here, I'm just going to print something out, so I'll just say like invalid input. So now, since I put this code inside of this try block, if the user enters in something wrong, it's going to be able to catch it. So it'll be able to catch what the user does wrong and print out invalid input onto the screen. So let's go ahead and run our program. And it's just going to say enter a number. So we're going to ignore that. We'll enter this in. And now instead of yelling at us and breaking the program, it just says, hey, invalid input. So it was able to handle the error that got called. It was able to handle the invalid input error. Basically just told us, hey, no more input. So this is a really powerful thing that we can do in our Python programs, basically just to protect our programs, right? If I want to have my program running for long periods of time, I can't have something as simple as an invalid input trip it up. So I can catch that invalid input using these try except blocks. But here's the thing, you'll notice that this little guy down here is getting highlighted. And let's just see what it has to say. So it's basically saying, too broad exception clause. And this is a message that we're getting because when I just say except, this will catch any error under the sun. So anything that can go wrong in my program, for the most part, this is going to accept it. So let me give you guys an example. Let's say I had in my program, I was creating a variable, right? So I wanted to create a variable called value, and I set it equal to 10 divided by 0. Now, if you know anything about math, you'll know that you can't divide a number by 0. It's not possible. So the program isn't going to be able to handle this, and you'll see that this is going to throw an error for us. So when I run the program, it basically says 0 division error, division by 0. We're not allowed to do that, right? If I took this and I put this down inside of this try block, and I just pasted it in here, it's going to get caught by this exception that we wrote down here. So it's going to get caught by that except. So when I run the program, you'll see it says invalid input. But the problem is that we didn't input something that was invalid, right? We just divided by 0, but it wasn't able to handle that, right? So it could not divide by 0, it threw an error. So even though we didn't get an invalid input, even though it was because we divided by 0, it still printed this out. And this brings me up to another point, is we can actually catch, or we can accept specific types of errors. So for example, in this case, we got a division by 0 error. In this case, we got an invalid input error, right? We put something in that was wrong. It couldn't convert the value. So I can create 2 different except blocks to catch 2 different types of errors. So down here, I can just make a space and I can specify the type of error that I want to catch. So when we divided by 0, it was 0 division error. So if I just put 0 division error in here, now it's going to catch that 0 division error. So I can say divided by 0. I could also make another except, so I could say except, and we can catch the other exception that we got. So I think it was a value error, right? It was, we put in the wrong type of value inside of that input. So now we can print out invalid input. So with these 2 except blocks, we're basically able to handle both of these situations. So for example, if this ends up breaking the program, this division by 0, then it'll be able to catch that. So down here, it'll tell us, hey, you divided by 0. But if I was to get rid of this line of code and I just entered in the number wrong, so I came down here and I entered in a string instead of a number, now it's gonna tell us invalid input. So we're gonna be able to specify what happens when certain things break. So when we get a value error, we can say invalid input. When we get a 0 division error, we can say divided by 0. So depending on what breaks, depending on what happens, we can actually do different things. And I want to show you guys one more thing we can do, which is we can actually store this error as a variable. So I can say except, and I can say as, and I can type in a name here. So a lot of times people will just say like ERR. And down here, I can print out the actual error. So I could just print ERR. And so if we end up dividing by 0, so if I say answer is equal to 10 divided by 0, we're going to throw this error and it's going to print out what went wrong. So now I can run this program and it just says division by 0. So it just printed out the error that we got. So that's another useful thing you can do, is you can actually like print out the specific error that got thrown. Now, a best practice in Python is to use these specific errors. So you always want to accept for a specific error. What you don't want to do is just say accept and then just accept anything under the sun. It's just too broad and it's not a good practice in Python. So you always want to be catching specific errors like this. In this tutorial, I want to talk to you guys about reading from external files in Python. Now, a lot of times in Python, you're going to want to read from files that are outside of your Python file. So you might want to read information from like a text file or a CSV file or like an HTML file. And you can actually use something called the Python read command, and it will allow you to read a file that is stored outside of your Python file. So you can use these files to get information, or you can parse through different files and do different things. So I'm going to show you guys the basics of reading files, opening files, closing files, doing all of that stuff. Over here I have this file called employees.txt. and it basically just lists out a bunch of different employees. Like these could be employees in an office or whatever. So it's just listing out all of this information. So let's say that inside of my app.python file, I wanted to read the employees inside of that file. The first thing I have to do is actually open that file from inside Python. So I can use a special command called open. So I can say open, and then in here I can type in the name of the file that I want to open. So this is either going to be a relative path to the file, an absolute path to the file, or just the file's name if both files are in the same directory. So in my case, app.python and employees.txt are in the same folder, like they're in the same directory, so I can just type out the name of the file. I can just say employees.txt. And then I want to put one more thing inside of this open function, and it's going to be the mode that I want to open the file in. So you can actually open files in a couple different modes, and the first mode is called read. So I can just put an R here, and that's going to stand for read. And this basically means that I only want to read the information inside the file. I don't want to modify it. I don't want to change it. I just want to read it. I just want to see what's in the file and do some stuff with that information. Another mode is called write. So I can type in this W. And writing basically means that you can change the file, right? You can write new information. You can change existing information. There's another one called A. And A stands for append. And this basically means that you can append information onto the end of the file. So you can't modify any of the information in the file. You can't change any of the information, but you can add new information. And there's one more, which is R+. And this basically means read and write. So this will give you all the power of reading and writing. So in our case, we're just going to be working with regular R. So we're going to be reading from the file. Now this open function will essentially just open the file. So it's going to like go over to that file inside of our file system, open it up, and it'll allow us to read through it. But generally we're going to want to store this opened file inside of a variable. So I can create a variable and we can just call it employee file. And I'm just going to set it equal to this open function. So now the open employees.txt file and all the content inside of it is stored inside of this employee file variable. Now, whenever you open a file, you always want to make sure that you close the file as well. So just like we have this open command, we also have an close function. So I can come down here and say employee file dot close. And this is essentially just going to close the file so we're no longer going to be able to access it. And generally, it's a good idea whenever you're opening up a file, you want to also make sure that you're closing the file at some point. So generally, once you're done reading it, you can just close it. So that's kind of like how we can open and close a file. Now, let's talk about how we can get information from the file, right? There's no point in having the file there if we can't figure out what's in it. So there's actually a few different functions that we can use on this employee file to figure out what's inside of it. And I'm going to show you guys some of those. So I'm just going to make a print statement, and inside this print statement, we'll basically just print out some information about the employee file. So the most basic thing we can print out is just the entire contents of the file. But before I do that, I want to show you guys how you can check to make sure that a file is readable. So before we do anything else, generally it's a good idea to make sure that it's possible to read this file. And there's a function inside of Python we can use called readable. So I'm just going to type out employee file dot readable, and this is going to return a Boolean value, and it's going to tell us whether or not we can read from this file. So I'm going to run my program, and you'll see down here we get a value of true, and that's because we set the file with a read mode. So it's in read mode, we can read from it. If I was to put a W here, so if I put like write, now readable is going to be false because we can no longer read the file, we can only write to the file. So I'm going to change this back to R so we can just read it. So once you figure out whether or not the file can be read from, let's actually read it. So there's another function called employee file.read, and this is basically just going to spit out all the information in the file. So when I run the program, it's just going to spit out all of this information, right? All the information that was in that file. I can also come down here and we could read an individual line inside this file. So I can say employee file dot read line. And what this is going to do is it's going to read an individual line inside of this file. So now when I run this program, you'll see it's just reading that first line in the file. And this read line function is actually just reading the first line, and then it's basically like moving a little cursor onto the next line. So if I was to copy this line of code and then print it again down here, I'm saying employee file.read line, so it's going to read the first line, and then when I say it again, it's going to read the line after that. So this is actually going to end up printing out the first two lines in the file. So when I run this program, you'll see we print out Jim salesman and Dwight salesman. So if I was to do this multiple times, like I could technically print out every line inside of this file. And you can see we can do that. And so that can be pretty useful for reading multiple lines in a file, but there's actually another function that is better at doing that. And we can say, instead of employee file.read line, we can say .read lines. And what this is going to do is it's going to take all of the lines inside of our file and put them inside of an array. And so now when I print this out, you'll see we have this array down here. It says Jim salesman, that's the first item in the array. Dwight salesman, the second item in the array. It's basically taking each line and putting it inside of an array. So if I wanted to access a specific line, I can just refer to it by its index in the array. So if I said 1, now this is going to give us that Dwight salesman line, because that is at index position 1 inside of the array. You can also use this read lines function with a for loop. So I could come up here and create a for loop. I'm just going to say for, and we'll say employee in employee file, and then for each employee we just want to print them out. So, and actually sorry, we have to put employee file dot read lines up here. And so now this will loop through all of the employees in this employee file dot read lines array, so we can actually just print out the individual employee. And now this will print out all the employees inside of that file. So it's basically printing out each line in the file. And that can be pretty useful. So you can use all of these different functions like read, read line, read lines, readable. You know, there's a bunch of these different things that we can do to get information from a file. And so there's a lot of cases where you're going to want to be able to parse through information in a file, and this is an awesome way to do it. So just to recap, whenever you want to open a file and read from it, you can just use this open function, type in the name of the file and then the mode, which in our case is going to be R. Then you can do all sorts of stuff with it, and you always want to make sure that you close it when you're done. That's just good practice. So that's the basics of reading from files, and hopefully you guys can use this in some way, shape, or form in the future. In this tutorial, I want to talk to you about writing and appending to files in Python. So one of the cool things about Python is it allows you to work with external files. So I could have like an external text file, and I could actually like completely read all of the information in it. I could parse through it, use that information to do certain things. But in addition to reading a file, I could also write a file. And that's what I want to talk to you guys about today, is writing new files and appending onto existing files. Over here, I basically just have some code written out, and this essentially just reads information from this employees.txt file. So you can see over here, I'm specifying the mode, which is R, and that stands for read. And then down here, I'm just reading all of the contents of the file and spitting it out on the screen. So I'm going to click the play button over here, and you'll see that this executes. So it's printing out all of the lines of code in our text file. So over here, I'm in this employees.txt file, and it just has all this information like employees in an office. But let's say that I wanted to add another employee onto here, right? Let's say that a new employee joined our company, so we wanted to add them onto this list. Well, I can come over here to my app.python file, and instead of reading from the file, I want to append to the file. So I want to say A. And appending to the file basically means that you're adding some text at the end of the file. So wherever the file ends, you're just going to add some text onto there. So what we can do is we can actually add another employee into the file. So instead of printing something out, I'm actually just going to say employee file dot write. And when I say employee file dot write, I'm going to be able to write something to the end of the file. So I can basically just write whatever I want. So why don't we add in another employee into our employees.txt file? So we can add in another employee. Why don't we say like Toby, and he's going to be in human resources. So now when I run this program, it's going to add Toby human resources onto the end of the file. So I'm going to run my program, and you'll see that nothing shows up down here in the console. But if I go over to my employees.txt file, all of a sudden we have a new entry over here. It's Toby from human resources, right? So I was able to append a line onto the end of this file. But here's the thing, you need to be careful when you're writing to files because you can actually mess up a file very easily. For example, I already added Toby here into my file, but if I was to run this program again, you'll see that over here in this employees.txt file, it went ahead and added Toby again, right? So it added this employee here again. And also you'll notice that in this case, this employee didn't go on to the next line. I accidentally ran my file again, and all of a sudden it messed up this file over here. And so appending, you really need to be careful because if you accidentally run your file again, or if you append something on something wrong to the file, it's permanent, like it's getting saved inside of the file. So I want to talk to you guys a little bit more about, appending. Another thing we could do, let's say we wanted to add another employee. And you'll notice over here in this employees.txt file, when I appended it on again, it got appended to the end of the existing line, right? So the first time I had a new line there, but if you don't have a new line at the end of your file, and you want to add a new line, you're going to have to add some special characters. So let's add another employee, and we'll call her Kelly. And let's just say Kelly is in customer service. So Kelly is going to be in customer service. And if I want to add this employee onto the end of the file in a new line, I'm going to have to put a new line character in front of it. So I can say \n, and this will append this entry into the file with a new line, so on a new line. So now when I run this, you'll see we get Kelly from customer service on her own line. So you want to make sure that you're aware of like these special characters that you can use. They call them escape characters. And anytime you're adding onto a file, you want to make sure that you're adding on exactly where you want to add on. So in addition to appending to a file, I could also just like overwrite a file, or I could write an entirely new file. So since we already have this open, instead of appending to the file, why don't we just write a file? So I'm going to use this W. And now, if I say employee file.write, because I'm using W and I'm not using A, it's actually going to override the entire file, and it's only going to put this inside the file. So when I run this and we go over to this employees.txt file, you'll see we only have one line inside of this file now. It's just Kelly customer service. That's because I was using W, not A. And when you use W, it's just overwriting everything that's in that existing file. You can also use W to create a new file. So over here, I could say employee file is equal to employees1.txt. And now what's going to happen is when I run this, it's going to create another file for me. So I'm going to run this, and you'll see over here in my file browser, we have this new file, employees1.txt. So if I open this up, it has exactly the same stuff as in this employees file. But it basically created a new file for us. And so a lot of times you're going to want to create a new file. And you can use different extensions too. So if I wanted to create like a web page, I could say index.html. And I could also add in some HTML code in here. So if you don't understand HTML, don't worry about it. But if you do, I could put like a paragraph in here, another paragraph, like this is HTML. Basically, HTML is like a web page. And the point I'm trying to make is that you could write out a web page inside of Python by doing something like this. So now when I play this, we get this index.html file, and it has some HTML inside of it. So that's one way that writing to files can be really useful. You can overwrite an existing file, you can write a new file and create it, or you can append on to the end of a file. And there's tons of applications for writing to files, and Python's a great language for working with reading, writing, and doing all that stuff with files. In this tutorial, I want to talk to you guys about using modules in Python. Now, a module is essentially just a Python file that we can import into our current Python file. So, for example, if I wrote a Python file that had a bunch of like useful functions or useful variables or other things like that, I could take that file, I could import it into the file I'm currently working on, and I could actually access all of those functions, all of those variables, all the stuff from that external file inside the file that I'm currently working on. So I'm going to show you guys how we can use modules, and then we'll talk about where you can find awesome modules and really why modules make Python an awesome language. So over here in my text editor, I actually created this file, and it's called usefultools.python. And basically this file just has a bunch of sort of like useful tools that I might want to use in one of my programs. So you'll see over here I have some variables. This one is telling me how many feet are in a mile. This one's telling me how many meters are in a kilometer. And then we have this list here which lists out all of the members of the Beatles. I also have a couple different functions down here. So I have this get file extension function. And this basically just will, you give it a file name, it'll tell you what the extension is. And then we have this other function down here which simulates rolling a dice. So you pass it a number. If I pass it like a 6, it would roll a 6-sided dice. If I pass it a 9, it roll a 9-sided dice, etc. So this is like a Python file that I wrote, and it has some useful stuff in it. And honestly, there's a lot of stuff in here that I might want to use in the other Python files that I work with. So let's say I'm over here at this app.python file, and I'm thinking to myself, I think I could use one of those functions that was inside of that useful tools file. Actually, yeah, I need to simulate rolling a dice in my program. Well, instead of having to go over here, copy this function, and then paste it over here into my program, I can actually just import this useful tools file, and I'll be able to import all of these functions and all of these variables and attributes. So the way I can do that is just by coming up here, and I'm just going to go right at the top of my file, and I'm just going to say import, and then I want to type in the name of the file that I want to import. So I'm just going to say useful_tools. And Python's going to be smart enough to know that it should go off and grab all the stuff from this usefultools.py file. So once I've used that import statement, I can actually use all of the functions inside of that useful tools file. So for example, I could simulate rolling a dice. I could say useful tools dot, and now I'm actually able to access all of the attributes from inside that file. So when I say useful tools dot, you'll see down here in my little suggestions menu, it's telling me like Beatles, feet and miles, get file extension, meters and kilometers, roll dice. So it's giving me access to all of the stuff that was in that file. So over here I could just say like roll dice, and we could pass this like a 10, we'll roll a 10-sided dice. And now this should actually be able to run that function. So we'll simulate rolling a 10-sided dice. So you can see we got 4. And this is a really core concept in Python, which is importing functionality from external Python files. And this is like huge in Python, and this is seriously going to change the way that you create your Python files. So you'll notice like I didn't have to copy any functions or any variables or anything over into this file, and yet I was able to use all the stuff that was inside this useful tools file. So that is huge, and honestly, it's going to save you a lot of time because you can write something once and then you can import it into your other files. And so that's really the basics of using modules. I mean, modules are very simple. A module is just any external Python file that you want to use some stuff inside of it. I want to show you guys a place where you can go to find a huge list of modules. So I'm going to go over here to my web browser, and I'm on this website. It's actually like the official Python docs. And basically all I did to get here was just type in list of Python modules in Google. And depending on the version of Python you're using, you're going to want to make sure that you click the right one. I clicked on the version 3 one. And over here on this page, you can see there's just a huge list of Python modules. And these are basically modules inside of Python that you can just access. So essentially there's like all of this awesome code that's already been written for you. And so if there's some sort of functionality that you want to have inside of your Python program, chances are there's a module in here that has that functionality. So there's all sorts of stuff you can do. I mean, if you just look through this list, like you'll see a huge collection of basically just, you know, a bunch of either Python variables or Python functions, just, you know, things that you can use to make your programs better. So here's what I would recommend. Like, head over to this page and just sort of look through a lot of these different modules, you know, see what you can see. And honestly, like if you click on one of them, it'll bring you to a page that talks about like how to use it. It'll tell you like how to import it and just, you know, some basics about it. And this is sort of like the list that's on the official Python docs, but here's the other thing. The Python community is huge. There's tons of developers who use Python, and you can actually find a lot of third-party modules. So if you just go online and, you know, look up like Python module for doing X or Python module for doing Y, chances are somebody out there has already written a Python module to do what you're trying to do. So if you get good at using modules and you get good at, you know, looking for them and finding them, you can actually save yourself a bunch of time, because chances are that somebody's already written a module to do, you know, what you're trying to do or like part of what you're trying to do. So now that we've taken a look at all these different Python modules, I want to just kind of dive in a little bit deeper into how we can actually use these things. So you'll notice here there's a lot of files, right? There's a lot of different modules that we apparently have access to in Python. But the question is, where are all these files stored, right? When I was over here in my program, for example, I was using this usefultools.py file. Like, I knew where that was. I created that file. I was directly involved in making it, and I just imported it over here. It was pretty easy, right? But what about all of these files, right? What about all of these modules over here? Like, where are all of these stored? And there's basically two types of modules here. There's built-in modules, which means they're just built into the Python language, so we kind of just automatically have access to them. And there's external modules. And a lot of these external modules are just stored in basically the same folder that we installed Python on our computer. So for example, let's look at a couple of these, right? We have like base64, BDB, bin ASCII. Like, if I come over here, and you'll see I'm over here in my little file explorer, I have my Python project, which is draft. There's also this other folder over here called external libraries. If I was to click down on this and I come down here, you can see it's just the version of Python that I'm using. There's a folder here called lib, and this is a very important folder. This is basically storing all of those external modules. So you can see if I scroll down here, we have all of these different like modules, right? So here's that base64, here's BDB, right? A lot of these external modules are stored inside of this lib folder. And like I said, there's external modules. There's also a few modules that are just like built-in modules. They're not going to be stored inside of here. And you can actually tell, so for example, if I was to come over here and click on base64, it tells me where the source code is. So the source code's in lib/base64. We were able to see that, right? I saw that inside of my lib folder. This bin ASCII though, for example, if I click on this, you'll notice that this isn't giving me a folder, because this is basically just like built into Python. So we don't have to worry about, you know, locating that file. It's just kind of like, it just kind of works. So some of these are external, some of them are built in, and I want to show you guys, in addition to using these modules, right? So there's a lot of good stuff here, and honestly, you could spend, you know, years and years just learning about all these different modules. But a lot of times you're going to want to use modules that other people have written, and you know, there's a lot of developers who work on Python and who write different modules. So there's a lot of useful modules out there that aren't included in this list, right? They're not going to be inside of this lib folder by default. And what we can actually do is we can install those external modules, those third-party modules that don't just come pre-installed with Python. And I'm going to show you guys how to do that really quick. So the first thing you need to do, obviously, is find a Python module that you want to install, that you want to download. And I have actually used one in the past, Python docs. It's an external module that you can use to basically use Python to create Word documents, which is pretty cool. So you can like format Word documents inside of it. So I'm just going to look that up here in Google. I'm just going to type in Python docs. And look, here's the thing. There's tons of these external modules. You don't have to use Python docs. I'm just giving you guys an example. But really, if you just look up like useful third-party Python modules, there's going to be lists of hundreds of these things online. In my case, though, Python Docs has a website, and it basically just has like some installation instructions. So I'm going to come over here, and it tells me that I can install Python Docs using the command pip install Python Docs. So this brings us to something I want to talk to you guys about, which is pip. And pip is essentially a program. And actually, if you have a newer version of Python 3, it comes pre-installed with Python 3. And you can use pip to install Python modules. It's referred to as a package manager. And a package manager basically just allows you to like install, manage, update, and uninstall like different Python modules. So pip is extremely useful. And in order for us to install Python Docs, we're going to have to use pip. So I'm going to show you guys how we can do that. What I want to do is open up the command prompt or the terminal on my computer. If you're on a Mac, you want to open up your terminal. If you're on a Windows computer, you want to open up your command prompt. I'm using a Windows right now, so I'm just going to come down to the search bar and type in CMD, and this command prompt should come up. So I'm going to click this. Inside of the command prompt, we can actually use pip. The first thing we want to do is just check to make sure that pip's installed. And like I said, if you have a newer version of Python 3, pip should come just pre-installed, and it should just work in here. If you don't have a newer version of Python 3 though, you might have to install pip separately. And there's tons of instructions online on how to install pip. So I'm just going to check to make sure that I have it. I'm going to type in pip -- version, and this should spit out the version of pip that I currently have. So as long as we have pip, then we're ready to install an external or a third-party Python module. All I have to do is just say pip install, and now I just want to type in the name of the Python module. So in the case of Python Docs, it was just Python Docs like that. Now again, you don't have to install Python Docs. I'm just doing this for this tutorial just to kind of show you guys how this is going to work. But you know, what you want to do is go online and look up some third-party external Python modules. And generally, like I'd say 90 to 95% of the time, you're going to be able to just install them using pip. In the off case that you can't install them using pip, chances are there'll be like some detailed installation instructions. But I would say for the most part, any like legitimate Python module is going to be able to install it using pip. So over here, I'm just going to say pip install and then the module name, so Python-docs. And when I click enter, this is going to go off and install Python Docs for us. So I'm just going to click enter, and it's going to go off and install everything we need for Python Docs. So you can see we successfully installed Python Docs 0.8.6. So I'm going to show you guys where exactly this got placed. So normally when we install a external third-party module, it's going to get put inside of this lib folder. But it's going to get put inside of a special folder in here called site packages. So site packages is a special folder, and if I open this folder, you'll see now we have this docs folder, and we also have this Python docs 0.8.6 py3.6.egg info folder. So these two folders are basically included in that module installation. So you can see this docs folder has a bunch of different Python files and has a bunch of stuff in here that we can use. So if I wanted to use this inside of one of my programs, I'm just going to refer to the name of the module. So in our case, it's just going to be docs. So I used Python docs in order to install it, but we're going to use docs if we want to import it. So I could come up here and I could say import docx, and now I can actually use it. So I could just say like docs dot whatever, and you can see there's a bunch of different stuff down here. There's like a document part, image part. There's a bunch of stuff that we can use with this. And obviously, depending on the Python module you install, there's going to be different instructions. But you can see it got stored down here in this site packages folder. If I wanted to remove this, I could use pip to do it. So I could just say pip uninstall, and we could just, again, say the module name, so Python docs. And pip will now uninstall this on our computer. So if I was to go back over to this folder, you'll see that those two, that docs folder and then that other folder disappeared. So they're no longer here, and I'm actually not going to be able to use this anymore. So that's sort of the ins and outs of using modules. Now again, there's tons of these modules, and I can make dozens and dozens of Python courses covering each one of these modules, the built-in modules, the modules that are included by default, and external modules. There's tons of these things out there. And really, as a Python programmer now, what you can do is you can go out and play around with these different modules. I showed you the ins and outs of installing them, and you can use pip to install all these different modules. And you can make sure that you have them by checking the site packages folder or the libs folder. But really now it's on you to just kind of go out and use these modules, and don't shy away from this, because modules are a huge part of Python, and you're definitely going to want to include them in your Python stack. In this tutorial, I want to talk to you guys about classes and objects in Python. Now, classes and objects are extremely useful in Python programming, and they can help you to make your programs more organized and more powerful. So when we're in Python, we're dealing with all types of data, right? And a lot of times when we're writing programs, we're going to have to work with different types of data. And there's essentially like a few basic types of data we can deal with, usually things like strings, so like plain text, numbers, and Boolean values. Those three are kind of like the main types of data that you're going to be working with in Python. And we have all sorts of structures we can use to store that data, things like lists or dictionaries. But here's the problem, is that not all information, not all data, not all things can be represented using strings, numbers, or Booleans, right? There's a lot of things in the real world that we can't represent in something like a string or just a number, right? In other words, think of something like a phone or a computer or a person, right? You can't really represent those things in like a string or a number. In other words, like the data types that we have available to us in Python can't cover that. And so what we can do with classes and objects is we can essentially create our own data types. So I can create my own data type for anything I want in Python. So I could create like a phone data type, and it could represent a phone. So I could store all the information I would ever want to know about my phone inside of that data type. And in Python, we could create a class for it. And essentially what a class is it's just saying, hey, here's another data type that we want to use in Python. So with a class, you can essentially define your own data type, and it's super awesome. And classes are extremely useful. Classes are used in almost every single major programming language out there. So in this tutorial, I just want to give you guys a basic introduction of classes and using them inside of Python. So let's say that I'm writing a program and I want to represent a student inside of this program. So maybe I'm writing a program for like a college or a university. Let's say that in this program, I want to model a student. Like I want to model a real world object and I want it to be a student, right? Well, we don't have a student data type, and I can't really represent a student in just a single string or a number. So what I can actually do is I can create a class for a student, and I'm basically creating like a student data type. So I'm going to show you guys how we can do that and create our student class. So over here, I'm just going to make a new file. We'll just make it a new Python file. So I'm just going to call it student.py. And inside of this student.py file, I want to create a student class. So the way that I can do that is just by typing class. And now I want to type the name of the class that I want to create. So in our case, we're going to create a class called student. So I'm just going to say student, and now we're going to make a colon. Now everything that goes inside of here is going to be inside of our student class. So everything that's indented like this will be considered a part of our student class. And basically what we can do inside of this student class is we can define a bunch of attributes about a student. So essentially what I'm doing is I'm like modeling a student. I'm creating our student data type. And I can use things like strings, integers, and Booleans in order to map out what a student should be and what a student should have. So I want to create something called an initialize function. And the way I do that is just by typing out def, and I'm just going to type 2 underscores, and then the word init, and then 2 more underscores. And you also want to type out open and close parentheses, and inside of those parentheses, we want to type out self, and then we want a colon after that. What I can do inside of this initialize function is I can basically map out what attributes a student should have. So we can essentially define like, hey, here's the student data type in Python. So what I want to do is add in certain attributes after this self. So I'm just going to say self, a comma, and now we can start thinking about, what values will represent a student inside of our Python program. So if I'm thinking something like name, right? So every student in our program should have a name. They also might want to have a major because they're in college. They probably also will have a GPA, so their grade point average, like how they're doing in school. And let's define one more thing. Let me think. Why don't we make a Boolean, and it's going to be called is on probation. And this will basically tell whether or not the student is on probation. So essentially what I'm doing inside of this initialize method, inside of this init function, is I'm defining what a student is in our program. And so in this program, a student has a name, it has a major, it has a GPA, and it has a value that determines whether or not it's on probation. This right here is the student data type. So if I'm representing a student inside of my program now, it has all of these attributes associated to it. And that's basically what I'm doing up here. Now, inside of this initialize function, we actually have to do something, and basically what I want to do is assign some values. So I'm going to be writing out some stuff, and this might not make total sense right now, but this is going to make sense in a second after we create our first student object. So just stick with me right now and just basically know that we have to do what I'm doing over here. So I'm just going to say self.name is equal to name, and then I'm going to say self.major is equal to major, self.gpa is equal to GPA, and I'm going to say self.is on probation is equal to is on probation. So again, this might not make a whole lot of sense right now, but in a little bit, this is going to make total sense. So now that I have this student class defined, I can actually use this class inside of my other files. So I'm going to come over here into this app.python file, and this is just my main file. And so I actually want to create a student, right? So in that student class, we defined the student data type, and we basically said like, hey, a student has a name, a major, a GPA, and it says whether or not they're on probation. That's like the template for what a student is. But we can actually create a student. So we can create an actual student and give it some information. And that's called an object. So this student class over here is basically defining what a student is. So a class is just like an overview of what the student data type is. An object is an actual student. So it's an actual student with a name, a major, and a GPA. It's not just this template anymore. It's actually like a student that we're representing inside of our program. So in order to use that student class and create a student object, I actually need to import that. So all I have to do over here is just say from student, and this is referring to this student file. I can say import student. And basically what this is saying is from the student file, I want to import the student class. So even though these are both student, they're referring to different things. So this is referring to the file, and this is referring to the actual student class. So now that we did this, we can create a student. So you can create an object of a class a lot like you would a normal variable. So I can just give it a name. I'm going to call this student1, and I'm just going to set it equal to student, and I'm going to make an open and close parentheses. And now inside of this parentheses, I want to give this student a name, a major, a GPA, and an is on probation value. So I'm going to say, we'll just create a fake student. So I'll just say his name's Jim, and he's studying business, and we want to give him a GPA. So maybe he has like a 3.1. And finally, we want to say whether or not this student is on probation. So why don't we say false? So basically what I'm doing is I'm saying that I want to create a student. So I want to actually create a student object. And remember, an object is just an instance of a class. So the class is like an overall template. It defines what a student is. But an object is an actual student with actual information. So we could call student1 now, this is a student object. So I just want to show you guys what this student object actually is and what we can do with it, and then I'm going to talk some more about that init function from before. So over here, I'm just going to make a print statement, and inside of here, I just want to print out student. And what's cool about this student1 object is I can actually access each of the attributes from inside of this object. So if I wanted to get the name of the student, I could say student1.name. And now this is actually going to print out the student's name. So over here, you'll see it prints out Jim. If I wanted, I could print out the student's GPA, and it's going to print out the student's GPA, 3.1. So now that I created this student object, I can actually access the information about the student. So essentially, I've just created a student data type. So I could create as many of these students as I wanted. If I wanted, I could create another student. We could call it student2. And essentially, we do the same thing. We just give it different information. So we could say like Pam, and her major is art, and she has like a 2.5, and let's say that she is on probation. So now I have another student, student2. So if I wanted, I could access information about that student. We could say like student2.gpa. And now this is giving me the GPA of student2. So basically what I did was I created a student data type, and I created student objects, and now I'm able to represent a student inside of my program. So let's talk real quick about all this stuff over here, because I didn't really explain it. Basically what's happening is when I come over here and I say student, and I'm passing in all of these different values, those are getting passed into this init function. So remember, I passed in a name, I passed in a major, I passed in a GPA. When we create that student, we're actually calling this function. And when I pass in the name, the major, and the GPA, those values are actually getting stored over here in this name, this major, this GPA, etc. Right? So I'm giving this student object all of that information. And down here, what I'm doing is I'm saying self.name is equal to name. And basically what this means is the actual object's name is going to be equal to the name that they passed in. So self.name is an attribute of student, right? So the student is storing a name, the student is storing a major, the student is storing a GPA. But that's different from this name, this major, and this GPA. Remember, these are all just values that I passed in. They're just parameters. And so I need to take the values that I passed in, and I need to assign them to the actual attributes of the object. So I need to say, okay, the name of the student is going to be equal to the name that we passed in. One more time. The name of the student object is going to be equal to the name that we passed in. The name of the student's major is going to be equal to the major that we passed in. The student's GPA is going to be equal to the GPA that we passed in. That's basically what's happening here. So when I say self, it's referring to the actual object. So over here, when I'm creating this student object, I'm giving it all of this information. It's taking that information and storing it as attributes for the object. So hopefully that makes sense. I think that's about as clear as I can make it. But the point is that now we have a student data type. So now I can represent a student inside of my Python program. And that's like super powerful. And what's cool about classes and objects is you can do this with anything. So in this example, we created a student class, and then we created student objects off of that. But I can model any real world entity into this program. I could model something like a phone, or I could model like a water bottle, or I could model, a keyboard, right? I could model anything that I wanted inside of my program. I could just give it certain attributes, right? And so that's what's cool about classes, is we can model real world objects and we can create our own data types. In this tutorial, I'm going to show you guys how to build a multiple choice quiz in Python. So basically, we're going to set up a little multiple choice quiz, and we'll have the user take the quiz, and as they take the quiz, we'll keep track of their score, and then at the end, we'll tell them how they did. So this is going to be a pretty cool video. I'm excited to show you guys how to do this, and we'll get to use things like classes and if statements and loops, in order to build this program. So we're going to use a lot of cool stuff in Python. The first thing I want to show you guys, I actually did this before I started the video. It's this little array. It's called question prompts. And I basically just wrote out all the questions that are going to be, or I shouldn't say the questions. I wrote out all the question prompts that are going to be inside of my multiple choice quiz. So the first one just says, what color are apples? And the answers are red, purple, or orange. The next one is, what color are bananas? The options are teal, magenta, and yellow. And the third question is, what color are strawberries? And the options are yellow, red, and blue. So this is obviously a very, very easy multiple choice quiz, but I just kind of wrote out the questions beforehand so I didn't have to spend time doing that. So let's talk about how we can build a multiple choice test. Well, the first thing I want to think about is, how can I represent the questions in the test, right? Over here we have the question prompts, but there's actually two parts to a question when you think about it. There's the prompt, in other words, like the actual question itself, and then there's the answer to the question. And both of those attributes need to be kept track of, right? I need to keep track of what we want to ask, and I need to keep track of what the answer is. So what I'm actually going to do is create a question class. So I'm going to create a little data type for questions, and inside of that question class, we'll be able to store the question prompt, and we'll also be able to store the question's answer. So I'm just going to come over here to my folder, and I'm going to make a new Python file, and we're just going to call this question.py. So we'll call it question.py. And inside of this question.py file, I'm going to make a class. So I'm just going to say class question, and I'm going to put a colon here. So inside of this question class, we want to define it in an initialize function. So I'm going to say def 2 underscores init 2 underscores, and then we're going to type out an open and close parentheses, self, and then a colon. So after this self, we want to define the different attributes that will describe or that will be included in a question. So we're going to include a prompt, and we're going to include an answer. So every question will have a question prompt and a question answer. And now down here, I want to take those values and assign them to the actual class object. So I'm going to say self.prompt is equal to prompt, and I'm going to say self.answer is equal to answer. So now we have a question class set up, and we can store all the information we need about a question. So what I want to do now is go back over to my app.python file, and we're actually going to create an array of questions. So I have over here these 3 prompts, and I'm actually just going to create another array. So we'll just call it questions, and I'm just going to set it equal to 2 open and close square brackets, and we're going to start creating question objects. So I can just say the first element in this questions array will be a question, and we want to pass question prompts 0, and the answer to the first question was A, red, green. That's the color of apple. So I'm going to pass that first question, and I'm also going to pass the answer, which is A. And you'll see down here I'm getting an error, so it's saying unresolved reference question. So actually what we need to do before we can create these questions is we need to import this question class. So I'm going to come up here and say from question import question. And so now down here in this questions array, we're not getting that error anymore. So we created one question object, and I'm just gonna create a couple more for these other ones. So I'm just gonna copy this one, and we will paste this down here. All right, so now we're creating 2 other questions, and these ones are gonna be 1 and 2. And the answer to the second question is C. And the answer to the third question, I think it's B. Let me look. Yeah, so it's C and B. All right, so essentially what we're doing is we're creating 3 questions. Each one is getting a different question prompt, and they're each getting different answers. So now we have an array of questions that we want to ask on our test. So the next step is to actually write a function that will run the test, right? It has to ask the user the questions, and it has to check to see if they got the answer right. So down here, lower in the file, let's create a function. So I'm just going to say def, and we'll call this run test. And inside of this parentheses, we're going to take one parameter into this function. we're going to take a list of questions. So I'm just going to say questions. So this is basically going to be a list of question objects that we want to ask the user. So once I'm in here, all I want to do is loop through all the questions. So I want to loop through each question. I want to ask it to the user. I want to get the user's answer, and I want to check to see if it's right. And we need to be able to keep track of how the user does through the test. So I want to create a variable called score. And I'm just going to set it equal to 0. So every time the user answers a question right, we'll increment this score variable. All right, so what I want to do is, like I said, loop through all the questions in that questions array. So I'm going to create a for loop. I'm going to say for question in questions. So in other words, for each question object inside of this questions array, I want to do something. And basically, the first thing I want to do is ask the user the question. And I want to store their response inside of a variable. So I'm going to make a variable down here called answer. And this is going to represent the user's answer to the question. And I'm going to set it equal to input. And I need to give this a prompt. So I'm actually going to give this the prompt for the question. So I can just say question.prompt. So now I have the answer that the user entered in, which is stored inside this variable. So we want to check to see if they got the question right. And I can do that using an if statement. So I can say if answer, and this refers to the student's answer, is equal to question.answer. So I'm checking to see if the answer that the student gave is equal to the answer of the current question that we're asking. And if this is true, then I just want to increment score. So I'm going to say score plus equals 1. And this basically just means we're adding 1 to the score. So the last thing I want to do inside of this function is just print out the result. So I want to print out how the user did. So down here, I'm just going to say print, and I'm basically just going to print out like, hey, you got like 2 out of 3 questions, or you got 5 out of 6 questions right, or you got 0 out of 10 questions right. We'll just print out how they did. So I'll just say you got, and now I want to print out how many questions they got right. So this is just going to be the score. And in order to print a number alongside of a string like this, I'm going to have to say str and then type in the number. So we'll say str score. So we'll basically say you got however many they got right out of, so we'll use this little / and now we'll just say how many questions there were. So we can say, and again, we're going to have to convert this to a string because it's going to be a number. So we can say string, and then we want to figure out how many questions were in that questions array. So I can say len, and inside of here we can just say questions. So this is kind of like this long statement just to print out how many questions there were. So then over here I'll just say correct. All right, so now we have this print statement, and it's just going to be printing out how many questions they got right. So let's see if this works. The last thing I need to do is just call this run test function. So I'll say run test, and I'm just going to pass it that questions array that we created before. So we created this questions array with all of these question objects inside of it. I'm basically just going to pass that into this run test function. So now let's run our program and see how we did. Hopefully we don't get any errors. There's a lot of code there, so it's possible that we might. Okay, so it says, what color are apples? This is a tough one. All right, let's put A, so we'll get the first question right. What color are bananas? Let's get the second question wrong. So I'm going to say B, bananas are magenta. And we'll get the third question right. So it says, what color are strawberries? I'll just put B because that's the right answer. So now you'll see that our program prints out, you got 2 out of 3 correct. So not only did it ask us all the questions and get our input for each question, but it also kept track of our score and it printed it out. So why don't we run through the test one more time, and we'll just like get 2 wrong this time. So I'll get this one wrong, I'll get this one wrong, and I'll get this one right. So now it says you got 1 out of 3 correct. So it's able to actually grade our test. And what's cool about the program we just wrote is if I wanted, I could add another question into here and it would automatically be able to ask it. So it doesn't matter how many questions we put in here. It's just able to ask it. So really the point I was trying to make with this whole video was just how we can use something like a class in order to model a real world entity. So for example, we created this question class and we were able to store all the information about a question that we could ever need. So we were able to store like the prompt and the answer. So we created our own question data type, and then we were able to create a bunch of different questions, pass it into this run test method, and it was able to grade the test and just run the test really easily. So that's kind of the point. So hopefully this makes sense. This was a lot of code, so if you don't fully understand what I did, go back, watch the video, try it a couple times on your own and see if you can create your own multiple choice test. In this tutorial, I want to talk to you guys about class functions in Python. So a class function is essentially a function that we can use inside of a class, and it can either modify the objects of that class or it can give us specific information about those objects. Over here, I have this student.py file. And inside of here, I created a student class. So I just had a class student, and I gave this student a couple of different attributes. I gave it a name, a major, and a GPA. So I can give this student all of this information. So when I create a student object, it'll have all of that information in it. Now over here on this app.py file, I actually created two students. So student 1 is Oscar, who's studying accounting, and he has a GPA of 3.1. Student 2 is Phyllis, who's studying business, and she has a 3.8. So what we can actually do is we can use functions inside of these class files. So I could actually define a function inside of this student class, and then all of my student objects could access it. So for example, I could come down here and create a function, and let's say we wanted to create a function that told us whether or not this particular student had honors. So whether or not they were on the honor roll, right? Basically, like, are they like a really good student? So I could define a function called onHonor, and basically what it's going to do, it's going to tell me whether or not this particular student is on the honor roll. And let's basically just say the rules for being on honor roll is you have to have a GPA of 3.5 or above. So if your GPA is 3.5 or above, that means you're on the honor roll. Well, over here, I could actually write the code for that. So I could say if self.gpa, and when I say self over here, this is referring to like the actual student's GPA. And you'll notice over here I have to pass that in as a parameter, and that always has to be the first parameter. So I could say if self.gpa is greater than or equal to 3.5, then we can return true, because this student is on the honor roll. Otherwise, else we can just return false, because if their GPA isn't above a 3.5, then they're not on the honor roll. So that's essentially our little on honor roll function. And you can see it's a very small function, but it provides a service to the objects of this class, right? It allows the objects of this class to figure out whether or not that current student is on the honor roll. So over in this app.py file, I could just print out that value. So I could say print, and I'm going to see if student 1 is on the honor roll. So now when I run this, you'll see it should print out false. And it's printing out false down here because student 1 only has a GPA of 3.1. If I was to do the same thing on student 2, student 2 has a GPA of 3.8, so we should return true. And that's exactly what happens. So essentially, a class function is just a little function that can be used by the objects of the class. And I would say this is a pretty good example of like what a class function should be doing. It should be like giving us information about the class, or it could also be like modifying information about the class. And so that's the basics of using functions in classes. I mean, this is a pretty simple tutorial, but I really just wanted to introduce you guys to the concept of putting functions inside of classes. This is going to be really useful, and if you're making a class, you always want to think about like what functions can I put inside of here that will, essentially help the user to either figure out information about the object or modify different values in the object. In this tutorial, I want to talk to you guys about inheritance in Python. Now, inheritance is basically where we can define a bunch of attributes and functions and things inside of a class, And then we can create another class and we can inherit all of those attributes. So I could basically have one class that has all the functionality of another class without having to physically write out any of the same methods or attributes. So if that's confusing, don't worry. I'm going to show you guys exactly what this is in this video. So let me show you about some stuff I have set up over here. I created this class called chef. And over here we just have this class chef. And inside of this chef class we have 3 functions. So this chef can do 3 things. The chef can make chicken, the chef can make salad, and the chef can make a special dish. And whenever the chef makes a dish, he basically just says, the chef makes a chicken, or the chef makes a salad, or the chef makes barbecue ribs for this special dish. It's basically just saying whatever the chef is doing. So if I was to come over here to my app.python file, you'll notice that I'm importing the chef. So I'm basically allowed to use this chef class now. And I can say my chef is equal to chef. So I'm creating a new chef. So now if I came down here and I said my chef dot make chicken, when I run my program, now it's going to say the chef makes a chicken. If I said make special dish and I run the program, now it's going to say the chef makes barbecue ribs, right? Because that's the chef's special dish. So I have this really awesome chef class and it works really well. But let's say that I wanted to create another class to model another type of chef, right? So this chef class is just modeling like some generic chef, right? We're representing some generic chef in our program. But let's say that I wanted to create a class that modeled a different type of chef. For example, let's say we wanted to create a class that modeled a Chinese chef. So instead of just a normal chef, this is a Chinese chef. Well, I actually created a file over here called ChineseChef.python. So we could actually use this ChineseChef.python file to create our Chinese chef class. So I'm just going to say class, and over here I'm just going to say Chinese chef, and basically I just can define everything that the Chinese chef can do. But let's say that our Chinese chef can do everything that our generic chef can do. So the Chinese chef is like a special chef, right? It's a very specific type of chef. But let's say that this Chinese chef can do everything that the normal chef can do. So the Chinese chef can make chicken, can make salad, and can also make a special dish. Well, if I wanted to give this Chinese chef all of that functionality, I could just come over here and I could copy all of these functions and I could paste them in here. And so now the Chinese chef can do everything that the other chef can do. But let's say that in addition to all of these things, the Chinese chef can also make a special dish called fried rice. So I could say def, and we could say make fried rice. So the Chinese chef has this extra function which allows it to make fried rice. And over here we could just say the chef makes fried rice. And let's also say that the Chinese chef has a different special dish. So instead of making barbecue ribs, the Chinese chef makes orange chicken. All right, so now we have our Chinese chef class set up, and you'll notice that it can do everything that the normal chef could do. So let's go back over to our app.python file, and I want to create a Chinese chef object. So instead of importing from chef, we're going to just import from Chinese chef. So I'll say Chinese chef, and we're going to import Chinese chef. So let's go ahead and make a Chinese chef object. So down here I'm going to make one, and I'll just say my, and then my Chinese chef, we can print out this special dish. So remember, the Chinese chef can do everything that the normal chef could do. So if I say my Chinese chef dot make special dish, when I run this program, you'll see the regular chef is making barbecue ribs and the Chinese chef is making orange chicken. So everything works out. And this Chinese chef also has an extra method called make fried rice, and he can also make fried rice. But here's the problem, right? When I go over here to this ChineseChef.py, when I wanted to use all of the functionality that was inside this chef class, I actually had to copy and physically paste all of these functions down into this file, right? And that's kind of a drag. I mean, especially like, imagine if this chef had like 20 or 30 of these different functions in it. Well, I'd have to copy and I'd have to paste all of those inside of this Chinese chef. And this is where we can use something called inheritance. So instead of having to copy and paste all of these functions, I could just inherit these functions from that chef class. And in order to do that, I can actually just get rid of all of these, and I can come over here and right next to where I'm saying class Chinese chef, inside of parentheses, I can say the name of the class that I want to inherit from. So I could just say chef. And I'm also going to have to import this. So I'm going to come over here and we'll say from chef, import chef. So basically what this is saying is inside of this Chinese chef, I want to be able to use all of the functions that are contained inside of the chef class. So I'll say that one more time. Inside of this Chinese chef class, I want to be able to use all of the functions that are inside of this chef class. So by using inheritance here, I'm actually able to come over here to this app.py file, and now I'm still able to execute, for example, like the make chicken function. Even though I didn't specify the make chicken function in here, I didn't write it out, I can still run this program and the Chinese chef will still be able to make chicken. So when I run this program, you'll see down here it says the chef makes chicken. And that's because I inherited the make chicken method from the chef class. But here's one thing that got messed up. If I come over here and I say make special dish, remember the Chinese chef special dish was supposed to be orange chicken, but now the Chinese chef is going to be making barbecue ribs because I inherited this make special dish function from this chef class. And so what I can actually do is I could come in here and I could override that make special dish class. So I could say def make special dish, and down here I can just override it. So I could say the chef makes orange chicken. And now when I go over here and I run this make special dish function, now the chef's going to be back to making orange chicken. So the Chinese chef will make his special dish. So that's basically what inheritance does. It allows me to inherit functionality from an existing class into the new class. And I can actually just inherit all of it without having to write it out. So I didn't have to write out make chicken and make salad inside the Chinese class, but the Chinese chef can still make chicken and salad because it inherited that functionality from the chef class. In this tutorial, I want to talk to you guys about the Python interpreter. The Python interpreter is basically a little environment that we can use to execute Python commands. So it's kind of like this little sandbox environment where we can test out and try out different Python commands or different Python functions in a very safe and neutral environment. So it's kind of like a quick and dirty way to write Python and try different things out. And the way we use the Python interpreter is by opening up our command prompt. Now, if you're on Windows, there's a program called Command Prompt. If you're on Mac, there's a program called Terminal. And basically, you need to open that program in order to use the Python interpreter. So I'm here on a Mac, but if you're on a Windows, you can essentially do exactly what I'm doing just inside of the command prompt. So on Mac here, I'm just gonna search for my terminal. If you're on Windows, you can just search for like CMD or command prompt and it should pop up. So the terminal is basically an environment on our computer where we can interact with the computer and do different things without a graphical user interface. So normally when we interact with the computer, we're using things like buttons or, windows, and, where we can move stuff around. We can, basically just like interact with the computer with graphics. But the terminal or the command prompt is a place where we can interact with the computer using text commands. So, I'm not going to get too much into what the terminal and the command prompt are, but that's essentially what it is. So inside of here, we can use the Python interpreter. And the Python interpreter is basically just a little program that, like I said, we can write, sort of Python in. So generally, all you have to do is go over to your terminal or your command prompt and type in Python 3. And since we're using Python 3, I'm going to type Python 3. But you can also just type normal Python, and I'm pretty sure that gives you Python 2. Now, here's a quick disclaimer. On Windows, you may run into a problem where you can't use this Python 3 command, and it's possible that if you're running into that problem, Python 3 hasn't been added to your Windows path variable. And basically what that means is your computer doesn't recognize the command Python 3. If that's the case, all you have to do is just go and Google how to add Python 3 to your Windows path variable. It's really easy. I'm not going to get into it in this video just because it's kind of outside the scope, but if you're running into that problem, that's probably it. It's not on your Windows path variable. So just Google around for that and you should be able to find an answer. But I'm going to type Python 3 and I'm going to click enter, and it's going to open up this cool little thing down here. So you can see it basically just says like, here's the version of Python. Now, I'm just going to enter so we can have some like new lines here. But down here, this is the Python interpreter. So we can write Python code in here and it's going to work. So I could, for example, I could write like print, and inside of here I could print like hello world. And when I click enter, you'll see that it prints out hello world. I could create a variable. So for example, I could say like num1 is equal to 10. I could say num2 is equal to 90. And then I could print out num1 plus num2, and it's going to be able to do that for me. I could also use something like a function. So I could define a function in here. We could make a function that's called say hi, and it'll take a name parameter. And you'll see here, when it saw I wanted to create a function, it put these 3 little dots, and I can indent in and we can write the code for our function. So I could say like print hello plus name. And now I have a function called say hi. So I can break out of this by just entering again. And I can call the function. So I could say hi, and we'll say hi to me. Hi, Mike. So now it's going to say, hello, Mike. So I can use a function. I could use something like an if statement, you know. I could say, I could use something like a for loop. We could use while loops. I mean, we can basically use all of the basic like Python commands and, you know, inside of this Python interpreter. And like I said before, it's essentially just an environment where you can test out Python code. Now, this is not a place where you want to write like any serious Python scripts. So if you're like designing and writing a Python program, I would not recommend doing it inside of this interpreter. It's not a very intuitive environment. It's pretty much just set up for some quick and dirty tests. If you need to test something out, great. This is a perfect place for it because you don't have to set up a file. You don't have to use like some IDE. You don't have to execute a file. You just go in here. It's quick. It's dirty. You get it done. But if you're writing like an actual program, you definitely want to use a text editor. The text editor, it's just going to be way more organized. Everything's going to be a lot clearer, and you're not going to get confused with like where stuff is and what you have. So that's the basics of the Python interpreter. You know, in the course, I haven't really been using it at all, just because I think it's a lot easier to teach when we're inside of a file than inside of here. But, you know, don't count this guy out. The Python interpreter is awesome. A lot of people use it, and it's great if you just need to test, you know, little bits of code out without having to set up some huge environment. So Python interpreter, definitely awesome. I would play around with it, you know, have some fun, and take advantage of it. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute and invest in our future.